Hello there, and welcome to Space Sleep Journey, where curiosity takes the gentle shape of a bedtime story and science moves at the pace of a quiet breath. I am so glad you are here tonight. Wherever you are, whatever kind of day you are carrying, you can set it down now. There is nowhere to be for the next few hours but right here in the quiet with me, drifting slowly towards sleep. Tonight we will be wandering toward one of the strangest questions in all of space, a question that sits right at the edge of what anyone knows. What is a white hole, really? Not a black hole, the door in the dark that swallows everything and lets nothing leave. Its mirror twin. Its exact opposite. A door hung backward, a place that nothing can enter and out of which everything must pour. The mathematics of gravity, the very equations Albert Einstein gave us in the year 1915, says such a thing is allowed as the black holes we have found everywhere we look. And yet, in all the vast and ancient sky, across all the years we have been watching it with ever sharper eyes, not a single white hole has ever been seen. So here is the real question we will drift through together tonight. If the equations allow it so freely, so calmly, why has the universe apparently refused to build even one? And what might that refusal teach us about time itself? But before we begin, I would love to know where you are listening from tonight. Perhaps you are in a bright and busy city where the glow of 1,000 streetlights washes the stars away and the night sky is only a pale and empty grey above the rooftops. Or perhaps you are somewhere quieter, out in the countryside, where on a clear night the Milky Way spills overhead in a great soft river of light, thousands of stars scattered from one edge of the dark to the other. Wherever you are, in the city or the country, near or far, awake in the small hours or just settling in, picture for a moment that we are looking up at the very same sky, you and I, together. Two small, warm points of wonder beneath the same enormous dark. It is a shared thing, this looking up. It always has been. If you find some peace here tonight, I would be grateful if you tapped like or subscribed softly, so that others who need a quiet voice tonight can find their way here too. It is a small thing, and it helps this gentle little corner of the dark reach the people who are looking for exactly this. And now, take a breath, a slow one, all the way in, and let it go. Settle into your chair, or your pillow, or wherever you have made your nest for the night. Let your shoulders drop. The day begin to loosen its hold. There is no hurry here, and nothing to finish, and nowhere to be. We have all the quiet hours ahead of us, and we are going to spend them wandering slowly and gently around one of the most beautiful ideas that physics has ever imagined and never once found. So let us begin. Imagine for a moment that you are floating in the deep dark of space, somewhere far from any world, far from any sun, in the great silence between the stars. And imagine that somewhere ahead of you, in that empty dark, there is a point where nothing at all should be. No star, no cloud of gas, no engine of any kind. Just emptiness and the cold and patient dark. And then, without warning, that empty point begins to pour. Light comes streaming out of it, and matter, a fountain rising out of nowhere, spilling outward into the night. You reach toward it. You try to draw closer. No matter how hard you push, no matter how you strain to reach that spilling point of light, you can never arrive. Something turns you away at the very edge, gently and absolutely, a shore you can approach but never land upon. You can only watch it pour, this fountain from nowhere, this door that opens only outward, giving endlessly and receiving nothing at all. Hold that image softly in your mind. That is the thing we are going to spend tonight trying to understand. So let us begin, slowly, with the simplest way I know to hold it. Let us begin with a door. Let me begin with a door. Picture a single door standing alone in the dark. It has no wall around it, no house behind it, nothing but the night on every side. And this door has a strange rule. It only opens one way. You can walk through it going in, and once you have, there is no walking back out. Push on it from the inside as hard as you like, lean your whole weight against it, and it will not give. That door, in the simplest words I can find, is a black hole. Place you can fall into and never leave. Now I want you to take that same door and hang it backward. Everything about it is the same frame, the same hinges, the same one-way rule. But the direction has flipped. Now the door only opens outward. Things come pouring through it into the world, streaming out into the night, and no matter how hard you push from the outside, no matter how gently you try to slip in, you can never cross to the other side. You cannot enter. You can only watch what comes out. Backward door has a name. We call it a white hole. And tonight, slowly and softly, with nowhere to be and nothing to rush toward, I would like to walk with you all the way around it. A white hole is the mirror image of a black hole. That is the cleanest way to hold it in your mind. A black hole is a region of space that nothing can leave, not even light, which is the fastest thing there is. A white hole is a region of space that nothing can enter, and out of which everything must eventually leave. Where the black hole is a trap that closes forever, the white hole is a fountain that only spills. One takes and never gives. The other gives and never takes. Two halves of the same strange coin. And here is the first quiet surprise of the night, the one we will keep returning to. The white hole is not a fantasy. It is not something a storyteller dreamed up and glued onto real physics to make it stranger. It is a real, valid solution to the equations that describe how gravity works. It falls out of the mathematics on its own, the way a shadow falls from a shape. If black holes are allowed, then by the deep symmetry of those equations, white holes are allowed too. The math does not flinch. It simply says, Yes, this is possible. The equations I am talking about come from a man named Albert Einstein, and from a theory he published in the year 1915, called general relativity, and it is our best description of gravity, of how space and time bend around anything that has mass. It has been tested for more than 100 years now, and it keeps passing. It predicted that starlight would bend as it passed the sun, and it did. Predicted that time would run a little slower deep in a gravity well, and it does, precisely enough that the clocks in the satellites over your head have to correct for it. This is not a shaky theory. It is one of the most carefully checked ideas in all of human knowledge. And this same trustworthy theory, when you follow it carefully, tells you that a white hole can exist. On paper, at least. In the clean, patient world of the equations, it is as real as the black hole standing beside it. So why then has no one ever seen one? That is the question I want to hold up to the light tonight and turn slowly and look at from every side. What is a white hole really? And if the mathematics allows it so freely, so calmly, why does the universe seem to have quietly refused to build one? We have found black holes everywhere we look. We have photographed them. We have heard them collide. Their mirror twins, the white holes, remain shapes in the equations and nothing more. Not a single one has ever been found in the sky. There is something wonderful in that gap, something worth resting inside of. The universe holds a possibility in its own rulebook, writes it down in plain terms, and then, as far as we can tell, declines to make it real. Tonight we will try to understand why. And in trying, we will end up learning something not just about white holes, but about time itself, about why the past is the past and the future is the future, and why the river of things only ever seems to flow one way. But we are getting ahead of ourselves. There is no hurry here. Let us go back to the door. I want you to really sit with the difference between the two doors, because the whole night grows out of it. When you fall toward a black hole, you cross a boundary called the horizon. The horizon is not a wall. It is not a surface you could touch. It is simply the line past which the pull of gravity has grown so fierce that to escape you would need to travel faster than light, and nothing can do that. So the horizon is a point of no return. Once you drift across it, every path you could possibly take, every direction you could possibly move, leads deeper in. The center is in your future now, as surely as tomorrow is in your future. You cannot avoid it any more than you can avoid the next moment of your life. Now run that whole picture backward in time, like a film played in reverse. Do you get? You get a horizon that works the other way. A boundary that no one on the outside can ever cross, going in. And instead of everything being pulled toward a center in the future, everything is flung away from a center in the past. Matter and light do not fall in and vanish. They appear and they leave. They stream outward across the horizon that nothing outside can penetrate. That reversed film, that mirror of the black hole, is the white hole. Same equations, same shapes, just time running the other way. And this is where I want to plant a seed that we will come back to again and again through the long middle of tonight. The white hole is what you get when you take a black hole and reverse time. So the question of why white holes seem not to exist is secretly a question about time. About why we can reverse the equations on paper so easily with a stroke of a pen, and yet the real world stubbornly refuses to run backward. You have never seen a broken cup gather itself up off the floor and leap back onto the table whole again. You never will. And a white hole, in a strange way, is that leaping cup, written into the language of gravity. Hold that thought gently. We will need it later. For now, let us just feel the shape of the thing. Imagine you are floating in empty space, a safe distance away, watching. In front of you, somewhere, is a white hole. You cannot see the thing itself because you can never receive anything that fell in. There is nothing that fell in. But you can see what comes out. Light comes out. Matter comes out. A steady, or perhaps sudden, outpouring from a place you can never reach. You could fire a probe straight at it, aim perfectly, burn all your fuel driving inward, and the probe would slow and hang there at the edge and never ever cross. The horizon of a white hole is a shore you can approach but never land on. There is a loneliness to that image, and also a kind of beauty. Place that gives endlessly and receives nothing. A one-way generosity written into the bones of the cosmos. Now, you might reasonably ask, if this is a real solution to real equations, where exactly did it come from? Who first noticed it? Was it something Einstein set out to describe, or did it sneak up on the people who came after him? And that, as it happens, is one of my favorite parts of the whole story, because the white hole was not invented. It was discovered, hiding inside equations that people had already been staring at for decades, folded up so neatly that no one saw it at first. It was there all along, tucked inside the black hole's own description, waiting for someone to unfold the map completely. To understand how something can hide inside an equation, we have to step back, all the way to the beginning, to the first time anyone wrote down what a black hole would look like. And to do that, we have to talk about a soldier doing mathematics by candlelight, on a battlefield, in the middle of a war, in the winter of 1915. So let us go there next, slowly, and meet the man who, without ever meaning to, sketched the first outline of the door that only opens outward. His name was Karl Schwarzschild, and he was, of all things, a soldier at the time, serving on the Eastern Front during the First World War. He was also one of the finest astronomers of his generation, a man who had run an observatory, who understood the mathematics of the heavens as deeply as anyone alive. When Einstein published his theory of general relativity in that same year, 1915, the equations at its heart were fearsomely difficult. They described how matter tells space how to bend, and how bent space tells matter how to move, all tangled together, all at once. Einstein himself doubted that anyone would find a clean, exact answer to them any time soon. They were simply too complicated. But Schwarzschild, in the cold and the noise and the fear of the front, sat down and solved them. He took the simplest interesting case he could imagine, a single round mass sitting alone in space, not spinning, not changing, just resting there, and he worked out exactly how space and time would bend around it. He did this while ill, while serving in a war that would soon take his life. He sent his solution back to Einstein, who was astonished and who presented it on his behalf. Within months, Schwarzschild was dead of a disease he contracted at the front. He never knew what his few pages would eventually reveal. What he had found is now called the Schwarzschild solution, and it is the mathematical description of the gravity around any simple, round, still mass. It describes the space around the Earth well enough, describes the space around the Sun. And when the mass is packed tightly enough into a small enough space, this same solution describes something far stranger. Describes a black hole. Buried in Schwarzschild's equations was a special distance, a radius, at which something dramatic happens. We now call it the Schwarzschild radius, and it marks the horizon, the point of no return. For the Sun, that radius would be only about 2 miles. For the Earth, less than an inch. Squeeze either one down small enough and it would wrap a horizon around itself and become a black hole. But here is the thing about Schwarzschild's solution, the thing that took decades to fully understand. When he wrote it down, the mathematics behaved very strangely right at that special radius. The numbers seemed to blow up, to break, to stop making sense exactly at the horizon. For years, physicists argued about what this meant. Was there a real wall there, a true edge to space? Or was the breakdown not in the universe at all, but only in the particular way Schwarzschild had chosen to draw his map? And that question, of whether the strangeness was in the territory or only in the map, is exactly where our white hole was hiding. Because the answer, when it finally came, would peel back the black hole's own equations and reveal that they described far more than one dark trap. They described a whole landscape, with regions no one had noticed, including a mirror universe and a door that opens only outward. But to see how that map got unfolded, we will need to leave Schwarzschild resting and travel forward in time by more than 40 years to the year 1960 and to 2 mathematicians who, working apart and unaware of each other, would each finish drawing the map that Schwarzschild began. Let us drift there now, gently, and see what they found. 2 mathematicians were named Martin Kruskal and George Szekeres, and the strange, quiet fact of history is that they solved the same puzzle at nearly the same moment, in the year 1960, without ever talking to each other. One was working in the United States. The other was working in Australia, on the far side of the world. And each of them, on his own, found the way to redraw Schwarzschild's map so that the false breakdown at the horizon melted away and the true shape of the thing stood revealed at last. I said false breakdown, and I want to explain that gently because it matters. Imagine you were looking at a flat paper map of the whole round Earth. Near the top and the bottom, near the poles, the map goes strange. Greenland looks as big as Africa, which it is not. The lines of longitude that should meet at the pole instead run straight up and never touch. If you trusted the flat map completely, you might think something terrible happens at the North Pole, some tearing of the world. But of course, nothing happens there. It is an ordinary place, snow and ice and cold. The strangeness was never in the Earth. It was only in the flat map, in the way we squashed a round thing onto a flat sheet. Choose a better map, and the trouble at the pole simply disappears. That is exactly what Kruskal and Szekeres did for the black hole. They found a better map, a better set of coordinates, a better way of laying out space and time on the page. And when they drew it their way, the horrible breakdown at the horizon, the place where Schwarzschild's numbers had seemed to explode, smoothed out into something perfectly ordinary. The horizon was not a wall. It was just a line on a badly drawn map. Nothing tears there. You could cross it without even noticing, the way a ship crosses the line where one time zone becomes the next. But when they drew the good map, the full and complete map, the one that showed the whole of Schwarzschild's solution stretched out as far as it would go, they found something they had not gone looking for. The map was bigger than anyone had realized. It did not show one region of space and time. It showed four. Let me walk you through the four, slowly, because this is the room where the white hole has been waiting all along. The first region is the easy one. It is the ordinary universe, the outside, the place where you and I and the stars all live. It is the space far from the black hole, where gravity is gentle and time flows the way it always has. Call it home. That is region 1. The second region is the inside of the black hole. It is what lies past the horizon, the trap, the place from which nothing returns. If you fall across the horizon, you enter region 2, and there the center lies unavoidably in your future. That is the black hole interior, and it is exactly what everyone expected to find. But then the map showed a third region and a fourth, and these are the ones that stop you in your tracks. The third region is another entire universe. A second outside, a mirror of our own, just as vast and just as ordinary, but separated from ours so completely that you could never travel from one to the other. It sits on the far side of the black hole, a whole other sky, a whole other version of home, unreachable. On the clean eternal map, our universe and this mirror universe are like two separate rooms that share a single strange wall. And the fourth region, The last one, the one we have been circling toward all night, is the white hole. It is the time reverse of the black hole interior, where region 2 is a place you can enter but never leave. Region 4 is a place you can leave but never enter. It is the source, the fountain, the door that opens only outward. It sits in the past of both universes, and everything that map allows to come pouring into our sky and into the mirror sky comes pouring out of it. Sit with that for a moment. The black hole, when you finally draw its full and honest map, is not a lonely trap sitting by itself. It comes bundled together with three companions, a mirror universe and a white hole, and a shared boundary linking them all. The white hole was never a separate invention. It was folded up inside the black hole's own equations from the very beginning, from the moment Schwarzschild set down his solution in the winter of the war. For more than 40 years it lay there hidden, simply because no one had drawn the map completely enough to see it. The answer was inside the question the whole time. I find that almost unbearably beautiful, and I want to let it settle over you like a blanket before we go on. We think of discovery as going out and finding something new, something far away, over the next hill or across the next ocean. But some of the deepest discoveries are the opposite. They are not far away at all. They are hiding inside something we thought we already understood, waiting patiently for us to look more carefully at what was in our hands the entire time. The white hole was not found in a telescope. It was found in an equation people had been reading for decades, an equation that had quietly contained it all along. Now, I have to be honest with you here, because honesty is part of the piece of this. Beautiful four-part map, the one with the two universes and the black hole and the white hole all bundled together, is what physicists call the eternal solution. It describes a black hole that has always existed and always will, that was never born and will never die, sitting unchanging for all of time. It is the purest, cleanest version of the mathematics. And it is not quite the same as a real black hole out there in the sky. A real black hole is not eternal. It was born. It formed when a giant star ran out of fuel and collapsed under its own weight, falling inward, crushing down, until it wrapped a horizon around itself. And when you do the mathematics for that story, for a real star actually falling in and forming a black hole, something interesting happens to our four regions. Two extra pieces, the mirror universe and the white hole, quietly fade away. They belong to the eternal, never born, never dying version. A black hole made from a collapsing star does not come with a white hole attached to its past, because it has a past, a time before it existed, when it was just an ordinary star shining in the dark. So the white hole in the clean map is a feature of the idealized mathematics of the eternal object that never actually forms. That is a crucial thread, and I will hold on to it and hand it back to you later, because it is one of the honest reasons the white hole stays a shape on paper. A genuine collapsing star does not build the pristine bridge to a white hole. Only the eternal, timeless, never-born solution does that, and there are no eternal, never-born black holes. Every black hole we know of had a beginning. But even so, even knowing that, the white hole refuses to simply disappear, because it is still there in the equations. It is still a valid solution all on its own. You can write down a white hole by itself, without any black hole beside it, and general relativity will accept it. It will say, yes, that is a possible way for space and time to be arranged. The theory does not forbid it. It hands it to you freely. And that is what makes the whole mystery so delicious. It is not that the white hole is impossible in the math. It is that the math allows it easily, and reality seems to refuse it anyway. The refusal is not written in the equations of gravity. It comes from somewhere else, from some other rule the universe obeys, and finding that other rule is the heart of tonight's journey. Before we go looking for that other rule, though, I want to give the white hole its human story, because ideas do not name themselves. Someone had to look at that fourth region on the map and give it a name, and think about what it might mean, and wonder aloud whether such a thing could ever be real. And that brings us to a Russian scientist working in the middle of the 1960s in the same handful of years that gave the black hole its famous name too. His name was Igor Novikov, a Soviet cosmologist, one of the sharp minds thinking hard about gravity and the cosmos in that era. In the middle of the 1960s, he took the idea of that fourth region seriously and proposed it as a real possibility to think about, a genuine time-reversed counterpart to the collapsing objects everyone was studying. And in those same years, as people needed a word for it, the name arrived, the natural opposite of the term that was just then coming into fashion for the dark trap. If a region from which no light escapes is a black hole, then a region from which light can only pour out and into which nothing can fall is a white hole. The names are mirror images, just as the objects are. There is something lovely in the timing of it. The same decade of the 1960s that gave black holes their name, that made the phrase black hole stick in the mind of the public and the physicist alike, also quietly named the black hole's twin. They were christened almost together, these two mirror ideas, one destined to be found everywhere in the sky, the other destined to remain a beautiful possibility on paper. The black hole would go on to become one of the most confirmed objects in all of astronomy. The white hole would go on to become one of the most elegant things we have never seen. And there was one more link, discovered even earlier, that ties the two together in a way that would go on to fire the imagination of nearly everyone who ever heard of it. 'Cause that shared wall between the black hole and the white hole, that boundary on the four-part map, is not just a wall. Under the right idealized conditions, it is a bridge, a tunnel, a throat connecting one mouth to another. And the two men who first found that throat, decades before Kruskal and Szekeres drew the full map, were Albert Einstein himself and a colleague named Nathan Rosen. What they found in the year 1935 is now called the Einstein and Rosen bridge, and it is the distant ancestor of an idea you have almost certainly heard of, even if you have never heard it explained slowly. It is the ancestor of the wormhole. So let us drift toward that bridge next, and walk out onto it carefully, and see what it really is and what it is not. In the year 1935, Albert Einstein was working with a younger physicist named Nathan Rosen, and the two of them were studying that same Schwarzschild solution, the description of gravity around a simple round mass. And they noticed something about its shape. If you looked at the geometry the right way, the space did not simply end at the center. Instead, it seemed to narrow down into a kind of throat, a bridge, and then open up again on the other side into another region entirely. Two funnels joined at their narrow ends. Two mouths connected by a tunnel. That tunnel is the Einstein-Rosen bridge. And in the full, eternal, four-part map that Kruskal and Szekeres would draw 25 years later, this bridge is exactly the throat that joins the white hole to the black hole and links our universe to the mirror universe on the far side. Matter that fell into the black hole mouth in this pristine picture would travel through the throat and pour out of the white hole mouth somewhere else, or perhaps someone else. Into another place. Into another time. Into another universe entirely. You can feel immediately why this idea has never let go of the human imagination. Tunnel through the fabric of space itself. A shortcut from here to a distant there. A way that what is swallowed in one place is reborn, spilling out in another. This is the seed of every wormhole in every story you have ever heard. The gateway. The portal. The bridge across the impossible distance. And the astonishing thing is that it did not begin in a story at all. It began in a pair of equations in 1935, worked out by the same man who gave us the theory of gravity in the first place. But I promised you honesty tonight, and honesty is the quiet floor that everything else rests on. So let me be very clear about what this bridge is and what it is not, because the difference is where so much confusion lives. This eternal bridge, this throat joining a black hole to a white hole across the fabric of things, is a feature of the idealized mathematics. Belongs to that clean, timeless solution, the black hole that was never born and will never die, sitting unchanging for all of eternity. In that pristine picture, yes, the bridge is there, and the white hole is there, waiting on the other side. A real black hole, the kind that forms when a real star collapses, does not build this pristine bridge. When you follow the mathematics of an actual star falling in on itself, the throat does something disappointing. Pinches off. Closes. It snaps shut so quickly that nothing, not even light, could ever pass all the way through it before it seals. The bridge exists for less than an instant, and it is never open wide enough or long enough to cross. The beautiful, permanent tunnel to a white hole in another universe belongs to the eternal solution, the one that never actually happens. The messy, real collapsing star gives you a black hole with a horizon and a center, and no white hole, and no crossable bridge at all. I do not tell you this to take the wonder away. I tell you because the real story is, if anything, stranger and more honest than the fantasy. The universe wrote down, in the language of its own gravity, a perfect tunnel to a fountain of light in another cosmos. It wrote it down clearly in the work of Einstein and Rosen, and then in the full map of Kruskal and Szekeres. And then, when it came time to actually build such things out of real collapsing stars, the universe closed the tunnel every single time, keeps the possibility on the page and refuses it in the sky. That refusal, again and again, is the pattern we're tracing tonight. And by the end, I hope you will feel it not as a disappointment, but as a clue, a fingerprint, a hint about how time itself is built. So let us take stock of where we are, quietly, before we go further. We have a white hole, the mirror of a black hole, a region nothing can enter and everything must leave. We have found that it is a genuine solution to Einstein's equations of general relativity from 1915. We have watched it emerge, hidden from Schwarzschild's wartime solution of 1916, unfolded at last by Kruskal and Szekeres in 1960 into a map with 4 regions. We have given it its name from Igor Novikov and that era of the middle 1960s. And we have walked out onto the Einstein-Rosen bridge of 1935 and seen that it is real in the eternal math and closed in the real world. And now we arrive at the question that a careful mind cannot help but ask. If the white hole is such a solid, respectable, well-credentialed idea, sitting right there in the same equations that gave us the black hole, then why do we treat the two so differently? Why do we speak of black holes as real objects, as things out there in the dark, and speak of white holes as curiosities, as maybes, as shapes on paper? What is the difference between them if the mathematics loves them equally? The difference is evidence. And I want to spend a while here, gently, on how much evidence there is for one and how little there is for the other, because the contrast is the sharpest way to feel the mystery. The black hole made a journey. It began, like the white hole, as nothing more than a solution to an equation, a shape in the math, something many serious scientists doubted could ever be real. For decades, even great physicists suspected that nature would find some way to prevent black holes from actually forming, that they were a mathematical curiosity and no more. Einstein himself was doubtful. And then, slowly, over the second half of the 20th century and into our own, the black hole climbed out of the equations and into the sky. The evidence came in piece by piece until it became overwhelming, until denying black holes became far harder than accepting them. Let me give you the great milestones of that journey, because each one is a marvel in its own right, and because they show you what real evidence looks like, the kind the white hole has never had. The first milestone I will name came in the year 2015, on the 14th day of September. On that day, a pair of enormous, exquisitely sensitive instruments, one in one part of the United States and one in another, felt a tremor pass through the fabric of space itself. Not a sound, not a light. A ripple in space and time, a gravitational wave, stretching and squeezing everything it touched by an amount almost too small to imagine, far smaller than the width of a single atom. These instruments, together called the Laser Interferometer Gravitational Wave Observatory, or LIGO for short, had been built to feel exactly that kind of ripple, and on that September day, for the first time in history, they felt one. The announcement came the following year, in 2016, and it changed astronomy forever. And what had made the ripple? Two black holes, far away, spiraling around each other, closer and closer, faster and faster, until they slammed together and became one. The collision was so violent that it shook the whole universe, sending out waves of pure gravity that travelled for more than 1 billion years across the dark, before washing, at last, over our tiny world and moving those instruments by a whisper. We did not see the black holes. We felt them. We felt the tremor of their meeting in the fabric of space. And the pattern of that tremor matched, with breathtaking precision, exactly what Einstein's equations predicted two merging black holes should sound like. That was the first time. There have been many since. We now feel these collisions regularly, a slow drumbeat of distant black holes meeting across the cosmos, each one a confirmation. The second milestone came a few years later, in the year 2019, on the 10th day of April. On that day, a team of scientists spread across the whole Earth released something no human eye had ever seen before. Picture of a black hole. Not a drawing. Not an artist's idea. Actual image, made from actual light, of the region around a real black hole sitting at the heart of a distant galaxy called Messier 87, a galaxy so far away that the light in the picture had been travelling toward us for tens of millions of years. To make that picture, they had turned the entire planet into a single telescope, linking dishes on mountain tops and in deserts all around the globe into one vast eye, an instrument they called the Event Horizon Telescope. And what they saw was exactly what the equations said they should see. A ring of glowing light, gas heated to unimaginable temperatures as it swirled around the edge, and in the centre a round patch of perfect darkness. The shadow of the hall. The silhouette of the door that only opens inward. There it was, at last, caught in a picture, the thing that Schwarzschild's wartime mathematics had first outlined more than 100 years before. And then, in the year 2022, the same worldwide telescope gave us a second portrait, and this one hit even closer to home. It was an image of the black hole at the centre of our own galaxy, the Milky Way, the great spiral of stars that you and I live inside. That black hole has a name. We call it Sagittarius A star, after the part of the sky where it sits. It is millions of times more massive than our Sun, and it has been there, quietly anchoring our whole galaxy for as long as the galaxy has existed. For years we had only inferred it was there by watching stars near the galactic center whip around something invisible at tremendous speed, circling a thing we could not see. And then, in 2022, we saw it, the same glowing ring, the same round shadow, the same signature of a horizon. The monster at the heart of our own home, brought at last into the light. So that is the black hole's resume. Felt directly through the ripples of its collisions, first in 2015. Photographed at the heart of a distant galaxy in 2019. Photographed at the heart of our own galaxy in 2022. Confirmed and reconfirmed from every direction by every method we can bring to bear. The black hole has fully, undeniably arrived. And the white hole? The white hole, its perfect mirror twin, born in the very same equations, named in the very same decade, one has ever been seen, felt, photographed, not detected by any instrument, in any way, ever, anywhere in the entire sky. Every white hole that has ever existed only as a shape in an equation, a possibility on paper, a door drawn in ink that no one has ever found hanging in the dark. In all the vast cosmos, across all the years we have been watching it with ever sharper eyes, the fountain that only spills has never once been glimpsed pouring. That is the gap I want us to stand inside for a while. Two ideas, equally allowed by the mathematics, equally elegant, equally the children of the same theory. One is everywhere. One is nowhere. And the deepest question of the night is simply this: why? Now, I said no white hole has ever been seen, and that is true, and I will keep saying it because it is the honest bedrock of the whole night. But I owe you one story before we go on, because there was once a moment when a few thoughtful people looked up at something strange in the sky and wondered, quietly, whether they might be looking at the closest thing to a white hole we would ever find. It was not one. Almost certainly it was not one. The story is worth telling slowly, because it shows you exactly how hard it is to catch such a thing, and how careful we have to be, and how the universe keeps handing us mysteries that look, for a moment, like doors that open outward. The story begins on the 14th day of June in the year 2006. On that day, a satellite orbiting the Earth, a spacecraft named Swift, built by the American Space Agency to watch the sky for sudden flashes of the most energetic light there is, caught one of those flashes. We call these flashes gamma-ray bursts, and they are among the most violent events in the entire universe. For a few seconds, a single gamma-ray burst can shine brighter than all the stars in a galaxy combined, pouring out more energy in a heartbeat than our sun will release in its entire lifetime of billions of years. They are the brightest explosions the cosmos knows how to make. This particular burst was given a name, in the plain way these things are named, after the date it arrived. It was called, simply, the burst of that day, marked by the numbers of its year and month and day. And from the moment the scientists looked closely at it, they knew something was wrong with it. Wrong, as in broken. Wrong, as in it did not fit. Did not behave the way a gamma-ray burst was supposed to behave. You see, by the year 2006, we thought we understood, in broad strokes, where these great flashes came from. There were two main kinds. The short ones, lasting less than a couple of seconds, we believed, came from two dense dead stars colliding. And the long ones, lasting many seconds or more, we believed came from a single giant star, dying, collapsing, and in its death throes blasting out a jet of radiation as its core fell in to form a black hole. And here was the key thing. When a long burst happened, when a giant star died that way, it should leave a mark. In the days and weeks afterward, as the wreckage of the dead star spread and glowed, we should see the light of a supernova, the great explosion of a dying star, brightening in the same spot. Long burst, then supernova. That was the pattern. That was the rule. The burst of that June day broke the rule. It lasted a long time, about 102 seconds, which put it firmly in the long category, the giant star death category. And yet, when astronomers watched the spot afterward, watching carefully, patiently, with powerful telescopes, waiting for the supernova to appear, it never came. There was no dying star. No great explosion brightened in the days that followed. A long burst with no supernova behind it. It was as if a giant star had died and left no body. The flash was there, enormous and undeniable, and the source that should have made it was simply missing. That was the puzzle. A tremendous outpouring of energy, lasting a minute and a half, from a place where the usual cause seemed absent. And a few years later, in the year 2011, two researchers named Alon Retter and Shlomo Heller looked at this strange sourceless flash and floated a bold and lonely idea. What if, they wondered, this was not a dying star at all? What if it was something pouring energy into our universe from nowhere we could point to, a sudden fountain of light and matter with no ordinary origin behind it? What if it was, in some small way, a white hole, briefly opening, spilling its contents into our sky, and then closing again? They even had a gentle name for the idea. They called it a small bang, a tiny echo of the great Big Bang that began everything, a little burst of creation instead of the one enormous one. Now, I want to be as clear and as honest with you here as I have tried to be all night, because this is exactly the kind of moment where a story can quietly slide from a maybe into a fact if the teller is not careful, and I will not let it. This idea that the burst of that June day was a white hole was never accepted. It was, and remains, a fringe hypothesis, a lonely suggestion at the far edge of the conversation, offered as a maybe and never adopted as an answer. Most scientists did not believe it then and do not believe it now. other, more ordinary explanations were proposed for the missing supernova. Explanations that did not require anything so exotic as a door opening outward in the sky. Perhaps the dying star was of an unusual kind. Perhaps the burst came from a merger after all, of a sort we had not fully understood. Perhaps the supernova was simply too faint or too far to see. Point is, the white hole idea was one voice among many and the quietest, and it never won the room. And yet I love that it was said at all, because it shows you the shape of the search. If we were ever going to find a white hole, this is roughly what it would look like from the outside. A sudden outpouring of light and matter from a place where nothing seemed to be, with no ordinary source to feed it, no infalling star, no visible engine. A fountain from nowhere. The burst of that June day was, for a brief moment, the closest thing the sky had ever offered to that description. And even it, our best and loneliest candidate, is almost certainly not a white hole. It is a reminder of how far the real thing is from us, that the nearest we have ever come is a single strange flash that most experts explain another way entirely. So let us hold that lesson and carry it forward, because it opens the door to what I think is the calmest and most wonderful stretch of the whole night. If a white hole would look, from the outside, like a fountain of light and matter pouring out of nothing, then how would we ever actually go about finding one? How would we tell it apart from all the other bright and violent things the universe does? How do we read the sky at all, and what tools would we need to say, with confidence, yes, that one, that is the door that opens outward, and not just another dying star? This is the question of measurement, of method, of how we know what we know. And I want to spend a long, unhurried time here, because the measuring is half the wonder. It is one thing to imagine a white hole. It is another thing entirely to imagine how a small, soft, curious species on a small blue world could ever hope to catch one across the immense dark. The story of how we read the sky is, to me, every bit as beautiful as the things we read there. So let us slow down and settle in even deeper, and walk through the tools one by which we would try to find a fountain from nowhere. The first and most fundamental problem is the strangest one, and it comes straight from the nature of the thing. A white hole, by its very definition, is a place nothing can enter. So we cannot look for what falls in. With a black hole, we have a great advantage. We can watch things fall toward it. We can watch gas spiral in and heat up and blaze with light as it circles the drain. We can watch stars orbit it and get whipped around by its pull. A black hole announces itself by its appetite, by the way it draws the world toward it, and we read its presence in the motion and the glow of everything falling in. That is how we found the one at the center of our own galaxy, by watching stars race around something dark and heavy. But a white hole eats nothing. Nothing falls in because nothing can. So the whole method we use for black holes, watching the meal, is useless. There is no meal. There is no infalling gas to heat up and glow. There is no swirling disk of doomed matter. A white hole is silent in exactly the way a black hole is loud. Gives no warning of its approach because it draws nothing toward it. We cannot find it by what it swallows because it swallows nothing at all. So we are forced to the other side. If we cannot watch what falls in, we must watch what comes out. And what comes out of a white hole would be a sudden appearance of matter and light, streaming outward from a point in space where, a moment before, there was nothing. No star. No cloud of gas. No visible engine of any kind. Just a spot in the empty dark, and then, without warning, a fountain. That is the signature we would be hunting for. Not an object that pulls, but a source that pours, with nothing behind it to do the pouring. And now the real difficulty begins, because the sky is full of things that pour. Stars pour out light. Exploding stars pour out light and matter both. Gamma-ray bursts, as we have seen, pour out staggering floods of energy. Quasars, the blazing hearts of distant galaxies, pour out more light than 100 billion suns. The universe is not a quiet place. It is full of fountains. So the question is not simply, can we find something pouring? The question is, can we find something pouring that has no ordinary source? And can we prove that it has no ordinary source, and not merely a hidden or faint or distant one? That is a far harder thing. And to even attempt it, we need to understand the tools by which we take apart light and read its secrets. So let us turn to those tools now, gently, one at a time, starting with the most powerful trick in all of astronomy, the trick of pulling a beam of light apart to see what it is made of. Here is a thing that still amazes me, no matter how many times I turn it over. Almost everything we know about the universe beyond our own small corner, we learned from light. We have never touched a star. We have never held a piece of a distant galaxy in our hands. We have sent our little machines only to the nearest few worlds, all of them huddled close around our own sun. Everything else, every star, every galaxy, every distant black hole, every far-off cloud of glowing gas, we know only because its light travelled across the dark and fell, at last, into our eyes and our instruments. Light is the one messenger that crosses the immensity to reach us. And so the whole art of astronomy is, at its heart, the art of reading light. Learning to squeeze every secret out of a beam that has travelled 1,000 or 1,000,000 or 1,000,000,000 years to arrive. And the greatest of those reading tricks is called spectroscopy, which is a large word for a simple and beautiful idea. When you take a beam of light and spread it out, the way a raindrop or a piece of glass spreads sunlight into a rainbow, you find that the light is not a smooth, unbroken band of colour. It is crossed by fine, dark lines and bright lines in very particular places. And here is the wonderful part. Those lines are a fingerprint. Every kind of atom, Every element, hydrogen and helium and oxygen and iron and all the rest, leaves its own exact pattern of lines in the light, at its own exact colours, like a signature written in the beam. No two elements leave the same pattern. The lines of hydrogen are the lines of hydrogen and nothing else. The lines of iron belong to iron alone. So when the light of a distant star or a distant explosion falls into our instruments, we can spread it out and read those lines, and the lines tell us what the thing is made of. We can stand on our small world and know that a star hundreds of light years away is burning hydrogen and helium. Know it as surely as if we had scooped up a handful and tested it in a laboratory, all because the light carries the fingerprint of its makers. A light year, by the way, is simply the distance that light travels in 1 year, and it is enormous, about 6 trillion miles. So when I say a star is hundreds of light years away, I mean it's light left it hundreds of years ago and has been racing toward us ever since, carrying its chemical signature the whole way. This is the first tool we would bring to bear on any suspected white hole. We would spread out its light and read the lines. And we would ask, what is pouring out of this fountain? Is it ordinary matter, the same hydrogen and helium and heavier elements that everything else in the universe is made of? Or is it something stranger? The truth is, we do not fully know what a white hole would spill, because we have never seen one, and here honesty requires me to say that the theory does not give us one clean, agreed upon fingerprint to hunt for. But spectroscopy would be our first question, always. Take the light apart. Read what it is made of. Let the lines speak. The second tool grows out of the first, and it is the one that unlocked the whole size and history of the universe, so let me take real care with it. It is called redshift, and it is one of the most quietly profound discoveries human beings have ever made. Remember those fingerprint lines in the light, the ones that tell us what an object is made of. Each line sits at its own particular color, its own particular place in the rainbow, and we know exactly where each one belongs because we can measure it in a laboratory here on Earth. The lines of hydrogen sit where the lines of hydrogen always sit. But when we look at the light of distant galaxies, we find something strange and telling. The lines are still there, still in their familiar pattern, so we can recognize them, but the whole pattern has slid. It has shifted toward the red end of the rainbow, toward longer waves altogether, as if the entire fingerprint had been gently stretched. That sliding is what we call redshift. And why does the light stretch? Here is the beautiful reason. The light stretches because the universe itself is stretching. Space is expanding, growing larger, carrying the galaxies apart from one another like raisins in a rising loaf of bread. And as a beam of light travels through that expanding space, across millions or billions of years, the space it is moving through swells beneath it, and the light waves are stretched along with it, drawn out to longer and longer wavelengths, sliding toward the red. Farther away a galaxy is, the more space its light has had to cross, the more that space has stretched during the journey, and so the more its light is reddened. The redshift, in other words, is a measure of distance and of time and of the expansion of everything. This is how we learned the universe is expanding at all. This is how we measure how far away the most distant things are. This is how we know that when we look far out into space, we are also looking far back into time, seeing things not as they are now, but as they were when their light began its journey long ago. When you look at a galaxy whose light has travelled for 1 billion years, you are seeing a billion-year-old photograph, a picture of how that galaxy looked when the light left it, a picture that has been in the mail, so to speak, for 1 billion years. The night sky is not a snapshot of now. It is a layered thing, near stars showing us the recent past, far galaxies showing us the deep past, all their ages mixed together in the same field of view. And this matters enormously for our white hole search, because redshift is how we would place any candidate in space and time. If we ever saw that fountain from nowhere, that sudden outpouring with no visible source, the very first thing we would do, after reading its chemical fingerprint, is measure its redshift to learn how far away it was and how long ago it happened. Was it nearby, in our own galaxy, or was it billions of light years off, at the far edge of the observable universe? Was it recent, or did it happen when the universe was young? The redshift would tell us. And in the case of that strange burst of the June day in 2006, part of the ordinary explanation that competed with the white hole idea involved exactly these kinds of careful distance measurements, working out how far away it truly was, and therefore how much energy it truly released, and whether that fit an ordinary source after all. This is the patient, unglamorous heart of astronomy. Measure the distance. Measure the energy. Measure the composition. And only then, after all the ordinary explanations have been tested and weighed, do you allow yourself to whisper the word extraordinary. Now let me add a third tool to the two we have, because a white hole, if it announced itself, might do so in a sudden flash, and flashes have their own language that we have learned to read. When something in the sky brightens suddenly and then fades, the exact shape of that brightening and fading tells us a great deal. How fast did it rise? How long did it hold? How slowly did it fall away? Astronomers call this shape the light curve, and it is like a heartbeat traced on a chart, and different kinds of events have different heartbeats. A supernova, the explosion of a dying star, brightens over days or weeks and fades over months, and the shape of its fade even tells us which kind of dying star it was, because the fading is powered by the radioactive decay of elements forged in the blast, and that decay follows its own steady clock. A gamma-ray burst, by contrast, flares in seconds and is largely gone in minutes, a far more sudden and violent heart. So the shape of the flash, the light curve, is another fingerprint, not of what the thing is made of, but of what kind of engine drove it. This is exactly the language that made the burst of that June day so puzzling. Its light curve, its heartbeat, did not match the usual patterns cleanly. Its duration said one thing, 102 seconds, a long burst. But other features of its shape said something more like a short burst. It sat in between, refusing to be sorted into either bin. And crucially, the long, slow afterglow that should have carried the signature of a supernova, that gentle weeks-long fade powered by radioactive decay, simply was not there. The heartbeat was wrong. The body was missing. That mismatch is what left a crack in the door, a small gap of not knowing, into which the lonely white hole idea could be quietly slipped before the more ordinary explanations eventually filled the gap instead. So now you can see the shape of the search, the real method by which we would ever try to find a door that opens out. We cannot watch it eat, because it eats nothing, so we must watch it pour. We spread out the light of anything that pours suddenly from an empty place, and we read its chemical fingerprint with spectroscopy to learn what it is made of. We measure its redshift to learn how far and how long ago. We trace its light curve, its heartbeat, to learn what kind of engine drove it. And then, and only then, we ask the hardest question of all. Is there any ordinary explanation for this? Any dying star? Any collision? Any known engine hiding just out of sight? 'Cause the rule of this work, the rule that keeps us honest, is that an extraordinary claim requires that we first rule out every ordinary one. And so far, every single time, the ordinary explanation has won, or at least has held its ground well enough that no one could honestly call the extraordinary one proven. That is why no white hole has ever been confirmed. Not because we have not looked, not because we lack the tools. Because the sky is full of ordinary fountains, and telling an extraordinary one apart from all of them, proving that a spill of light truly has no source, is a bar so high that nothing has ever cleared it. The white hole remains beyond the reach, not of our imagination, but of our proof. And there is a deep peace in admitting that, in saying plainly, we do not know, we have never found one, and it may be that we never will. Not every question the universe poses has yet been answered. Some of them we are still holding, unopened, turning them over in the dark. But before we ask whether a white hole could even be there to find, there is one more tool for reading the sky that I want to place in your hands, because it is perhaps the most magical of them all, and it comes straight from the same theory that gave us the white hole in the first place. So let us stay with the measuring a little longer, gently, and pick up that last tool before we turn toward the deeper question of whether the fountain could exist at all. There is one more tool for reading the sky that I want to place in your hands before we leave the long, calm work of measurement behind, because it is perhaps the most magical of them all, and it comes straight from the same theory that gave us the white hole in the first place. It is called gravitational lensing, and it is the way we use gravity itself as a kind of enormous natural telescope. Here is the idea, told slowly. Einstein's theory tells us that anything with mass bends the space around it, and that light traveling through bent space follows the curve. So when the light of a distant object passes close by something very massive on its way to us, a galaxy, a cluster of galaxies, a black hole. That light does not travel in a perfectly straight line. Bends around the massive thing, the way a stream bends around a stone. And if the alignment is just right, the massive thing in the middle acts like a lens, gathering and focusing the light of whatever lies behind it, magnifying it, sometimes smearing it into arcs and rings, sometimes splitting a single distant object into several images spread around the lens. We have photographed these rings of light, these smeared and multiplied images, and each one is a place where gravity has bent the path of ancient starlight and bent it toward us, letting us see things far too faint and far too distant to see any other way. Think of what that means. We can weigh things we cannot see by watching how they bend the light of things behind them. We have mapped vast amounts of unseen matter across the cosmos this way, tracing its presence purely by the way it warps the light passing through it. And this same trick would be one of our tools in any hunt for a white hole, because a white hole, having tremendous mass and tremendous gravity, would bend the light around it just as a black hole does. It would leave a fingerprint in the paths of the light behind it, a warping, a lensing that we could in principle read. So even a thing that pours light outward and swallows nothing would still announce its mass by the way it curved the ancient light streaming past it from the deeper dark beyond. But here I have to be honest with you again, because honesty is the quiet flaw beneath everything tonight, and this is exactly where the difficulty bites hardest. Gravitational lensing tells us that mass is present. Does not, on its own, tell us whether that mass is a black hole, or a white hole, or a dense cloud of dark matter, or an ordinary, if invisible, clump of stuff. From a distance, from the way it bends light, a white hole and a black hole of the same mass would look very much alike. The lensing is the same. The gravity is the same. The difference between them is not in how they pull, but in what they do at their horizons, whether things fall in or pour out, and that is a far subtler thing to catch across the immense gulfs of space. So even our most magical tool, gravity used as a telescope, would leave us squinting at an ambiguity, unable to say for certain which kind of door we were looking at. And this is the deep reason, underneath all the others, that no white hole has ever been confirmed, even in principle, even with every tool we have. It is not only that they may not exist. It is that if one did, telling it apart from all the ordinary things the universe does would be extraordinarily hard. A sudden outpouring of light could be a dying star, or a collision of dead stars, or a flare from the disk around a black hole, or a dozen other ordinary engines. A warping of distant light could be any massive thing at all. To prove a white hole, we would have to catch an outpouring of matter and light from a point with no visible source, with no infalling gas to feed it, with the mass to bend the light around it, and then rule out, one by one, every single ordinary explanation until the only thing left standing was the extraordinary one. And the sky is so full of ordinary fountains, and our view of it so often clouded by distance and dust and faintness, that this bar has never once been cleared. Not for the strange burst of that June day in 2006. Not for anything, ever. I want you to sit with that difficulty for a moment, not as a frustration, but as a kind of humility, a gentle reminder of how careful we have to be and how far the real thing is from us. It would be easy, so easy, to point at something strange in the sky and cry, "A white hole, at last." People have felt that temptation. The discipline of the work, the thing that keeps us honest, is the rule that an extraordinary claim must survive the ruling out of every ordinary one. That rule is slow. It is unglamorous. It has disappointed many a beautiful hypothesis. And it is exactly what makes the knowledge we do have trustworthy. When we say we have found a black hole, we mean we have ruled out, patiently and exhaustively, everything else it could be. And when we say we have never found a white hole, we mean, with the same patience, that nothing has ever survived that ruling out. Absence is not carelessness. It is the honest result of looking hard and refusing to fool ourselves. There is a peace in that discipline, I think, that reaches beyond astronomy. It is the peace of a mind willing to say, "I do not know," and to keep saying it until the evidence truly comes in, rather than reaching for a comforting answer too soon. So much of the trouble in a life comes from grabbing at an answer before the evidence is in, from deciding what something means before we have really looked. The patient sky teaches a slower way. Ja, the watch. Measure. Rule out the ordinary. And hold the extraordinary lightly as a maybe until it earns the right to be more. The white hole has never earned that right. And there is no shame in its remaining a maybe, a beautiful shape in the equations, a question still open. Not every question has an answer yet. Some of them we are still holding, gently, unopened, turning them over in the dark, and that holding is its own kind of wisdom. So let us leave the telescopes and the lenses and the careful ruling out behind us now, having given the measuring its full and patient due, because the measuring truly is half the wonder and half the honesty too. We have seen how we read the sky and how hard it would be to ever read a white hole out of it. And now we turn from the question of whether we could ever find one to the deeper question of whether one could even be there to be found. And that question takes us to the two great walls and to the law of disorder and to time itself. So let us drift toward that first great wall now, gently, and understand why the universe may have forbidden the very thing its own equations allow. Let me start with something small and ordinary, something from your own kitchen, because the deepest law standing against the white hole is a law you have felt every single day of your life, even if no one ever gave it a name. Imagine you drop a glass and it shatters on the floor. The pieces scatter. The sound rings out. And it is gone in an instant from one whole thing into 100 broken ones. Now imagine watching that in reverse. The shards lift off the floor. They rush together. They knit themselves back into a perfect glass, which leaps up into your waiting hand, whole and unbroken, the sound running backward into silence. you have never seen that happen. You know in your bones that you never will. A glass shatters. A glass does not unshatter. The film of your life only ever runs one way. Now think of a drop of ink falling into a glass of clear water. Blooms, it spreads, it swirls out into pale clouds, until the whole glass is evenly tinted and the ink is everywhere and nowhere. And you know, without being told, that it will never gather itself back into a single dark drop, leaving the water clear again. Think of a hot cup of tea sitting on a table. It cools. The warmth spreads out into the room. And the room never ever gathers its warmth back up and pours it into the cup to make the tea hot again on its own. Heat spreads out, does not gather in. Things fall apart. They do not fall together. There is a single deep principle underneath all of these everyday truths, and it is called the second law of thermodynamics, and it is one of the most powerful and unbreakable rules we have ever found. In plain words, it says this: in any closed system left to itself, disorder tends to increase. It can hold steady in special cases, but it essentially never decreases on its own. The scientific word for this disorder is entropy. So the second law says, simply, that entropy tends to grow. The shattered glass has more entropy, more disorder, than the whole one. The spread ink has more than the single drop. The warm room has more than the hot cup in the cool air. And the universe, as a whole, is always sliding in that direction, from order toward disorder, from the drop toward the cloud, from the whole glass toward the shards. Sit with how strange and how total this is. Nearly every other law of physics works just as well running backward as forward. The equations that describe two billiard balls colliding do not care which way time flows. Play the film of a collision in reverse and it looks perfectly natural, perfectly legal, nothing wrong with it at all. The same is true, as we have seen all night, of the equations of gravity. They do not care about the direction of time. That is the whole reason the white hole exists in the first place. It is the black hole with time reversed, and gravity has no objection. But the second law is different. The second law has a direction built into it, knows the difference between forward and backward. It is, as far as we can tell, the deepest reason that time seems to flow one way, that we remember the past and not the future, that we grow older and never younger. The glass shatters and never mends. The steady growth of entropy, the endless spreading out of things, is what physicists sometimes call the arrow of time. It is the one arrow that points always from past to future, and it is stitched into the fabric of reality by this single humble law about disorder. And now, gently, I want you to see what this has to do with our door that opens out. Because a black hole, it turns out, is not just a trap for matter and light. It is also, in a deep and surprising way, the tiniest engine of disorder that the universe has ever built. This was one of the great discoveries of the 1970s, and it came from the work of two remarkable minds, a young physicist named Jacob Bekenstein and, building on his idea, the physicist Stephen Hawking. What they showed, working through the mathematics, is that a black hole carries entropy, and not a little of it. A black hole carries an almost unimaginable amount of disorder, more than anything else of its size in all the cosmos. And they found something precise and beautiful about how much. The entropy of a black hole, the amount of disorder it holds, is tied not to its volume, but to the area of its horizon, the surface of that one-way door. The bigger the horizon, the more disorder the black hole contains, growing with the surface of the thing. Let me make that vivid, because it is easy to say and hard to feel. When matter falls into a black hole, all the intricate order of that matter, the arrangement of its atoms, the structure of whatever it once was, a star, a planet, a cloud of gas, all of that is swallowed, and the black hole simply grows a little larger, its horizon a little wider, its store of disorder a little greater. A black hole is where order goes to disappear. It is the ultimate destination of the second law, the deepest drain in the whole universe, into which the order of things can vanish and the total disorder can climb. Matter falls in. The horizon grows. The entropy rises. The arrow of time points inward, always inward, from the ordered outside to the disordered dark within. A black hole is the second law made into an object. It is disorder given a shape. And now, at last, we can see the wall the white hole runs into, and it is a wall built out of this very law. Take the black hole, that great tidy engine of growing disorder, and reverse it in time as we have done all night to make our white hole. Does the reversal do to the entropy? Flips it. Where the black hole takes ordered matter and swallows it into disorder, the white hole, run backward, would take disorder and spit out order. Where the black hole's horizon grows as it eats, the white hole's would shrink as it pours. Where matter falls into the black hole and vanishes, matter would come streaming out of the white hole and assemble, appearing from nowhere, organizing itself, order emerging spontaneously from an empty point in space. The white hole, in short, would be a machine for making entropy go down, for running the film backward, for gathering the ink back into a drop and knitting the glass back together and pulling order out of chaos. And that is exactly, precisely, word for word, the one thing the second law of thermodynamics says the universe does not do. This is the first great wall, and I want you to feel its full weight, because it is the strongest reason of all that physicists doubt the white hole can truly exist as a lasting object. It is not that the equations of gravity forbid it. They do not. Gravity, we have seen, is perfectly happy to run either direction, and hands us the white hole freely. The forbidding comes from somewhere deeper, from the one law that does know the direction of time. The white hole is not blocked by the rules of space and gravity. It is blocked by the arrow of time itself. It is a thing that would require the universe to run backward, to let disorder decrease, to let the shattered glass leap up whole, and the universe, as far as we have ever been able to tell, simply refuses to do that. Not once. Not anywhere. Not ever. There is something almost solemn in that, and I want us to rest in it for a moment before we go on. The white hole is a perfectly legal shape in the mathematics of gravity. Einstein's equations of 1915 allow it without complaint. And yet a second, deeper law, the law of disorder, the law of the shattering glass and the spreading ink and the cooling tea, seems to reach in and quietly veto it. Two of our most trusted laws, both of them tested countless times, both of them true, and on this one strange object they seem to disagree. Gravity says, this is allowed. Thermodynamics says, this cannot last. And nature, when the two disagree, appears to side with thermodynamics, with the arrow of time, with the one-way flow of things. The universe would rather keep its arrow pointed forward than build the beautiful door that Einstein's equations left open. I find that one of the most moving facts in all of physics, and here is why, means that the absence of white holes is not a boring gap in our knowledge, not merely a thing we have failed to find. It is a positive fact about the world. It is a fingerprint of time itself. The reason the sky is full of black holes and empty of white ones is the same reason your memories run from the past toward the present and never the other way. The same reason you were young and are older and will not be young again. The same reason the glass on the floor stays broken. The missing white hole and your own one-way journey through time are, at the deepest level, the same fact, wearing two different faces. To ask why there are no white holes is, secretly, to ask why time flows forward. And that is a question that touches everything, every life, every moment, every breath you have ever taken and will ever take. But I have to be careful and honest here, as I have tried to be all night, because I do not want to hand you the second law as a slammed and locked door with no argument left inside it. The truth is a little softer than that, and the softness is where the wonder lives. The second law is a law about what tends to happen, about the overwhelming likelihood of things, about the direction the universe strongly prefers. It is not, in the same way as gravity, a law about what is strictly, absolutely, mathematically impossible in every conceivable instant. Physicists argue, carefully and seriously, about exactly how ironclad the ban on white holes really is, about whether there might be special circumstances, brief moments, quantum loopholes, in which something white hole-like could flicker into being before the arrow of time reasserts itself and shuts it down. We will come to those arguments and to the frontier where a few serious scientists are trying, right now, to bring the white hole back to life inside a deeper theory. Case is not fully closed. The second law is the reason most physicists, most of the time, expect that it stays closed. It is the Great Wall, and it is a very high wall, even if it is not a perfectly seamless one. And there is a second wall too, standing right behind the first, and it is a different kind of argument entirely. The first wall, the second law, says the white hole should not exist because it would run time backward. The second wall says something even more practical and more brutal. It says that even if a white hole somehow did exist, even if the universe let one form, it would not last. It would destroy itself almost at once and turn into the very thing it is the opposite of. So let us turn to that second wall now, the wall of instability, and see how the fountain that only spills would choke on the first stray breath of the cosmos and collapse back into darkness. The second wall was found in the year 1974 by a physicist named Douglas Eardley, and it is a wonderfully clever and slightly cruel little piece of reasoning. To feel it, we have to remember one thing about the universe, a thing that is easy to forget when we imagine these clean, isolated objects floating in perfect emptiness. The universe is not empty. Truly. Not anywhere. Everywhere you look, even in the darkest gulfs between the galaxies, there is a little something. A thin drift of gas. A scattering of stray atoms. A faint bath of light left over from the birth of the cosmos, glowing softly at every point in the sky. Space is very nearly empty, emptier than any vacuum we can make on Earth, but it is never perfectly, absolutely empty. There is always a little matter, a little light, a little something drifting through even the loneliest reaches. Now, a white hole is, like a black hole, a thing with tremendous gravity. Pulls. Its horizon may only let things out, but its gravity still reaches across the surrounding space and tugs on everything nearby, the same way the black holes does. So imagine a white hole sitting in space, and imagine the thin drift of gas and light that fills all of space beginning, slowly, to fall toward it, drawn by its pull. This is unavoidable. There is always some matter around, and gravity always pulls, so matter always begins to fall in. But here is the trap, the beautiful and terrible trap. The white hole is a door that opens only outward. Nothing can cross its horizon going in. So all that in falling gas and light, drawn by the white hole's gravity, rushes toward the horizon and then cannot get through it. Piles up. It slows. Gathers just outside the door that will not open for it, in a thinner and thinner, denser and denser shell, waiting at a threshold it can never cross. And as it waits there, pressed against the horizon of a thing it cannot enter, something dreadful happens to it. The light and matter caught at that threshold get squeezed and concentrated and, in the language of physics, blue shifted, their energy climbing higher and higher, piling up without limit, growing more and more intense as they hang there against the door. Eardley showed, with the mathematics, that this pile-up is not gentle, and it is not slow to matter. It runs away, grows exponentially, feeding on itself, the trapped energy at the horizon climbing higher and higher until it becomes overwhelming. And when enough energy and matter has concentrated there at the very edge of the white hole, the gravity of that piled-up shell takes over. It collapses. It forms a horizon of its own. And that horizon is a one-way door that opens inward. In other words, the white hole, choked by the ordinary matter of the universe pressing against its outer edge, turns into a black hole. The fountain that only spills becomes the trap that only swallows. The door that opened outward slams shut and reverses, and what was the mirror of a black hole simply becomes a black hole, plain and ordinary, like all the others. And how long does this take? That is the cruelest part. It does not take a long, comfortable age. By Eardley's reasoning and the work that followed it, even the tiniest disturbance, even the faintest drift of the thinnest gas is enough to trigger the collapse, and it happens fast, catastrophically fast. The universe is simply not empty enough anywhere to leave a white hole standing. There is always some stray matter to fall toward it, always some faint light to pile up at its door, and that is always enough to choke it and flip it and turn it dark. A white hole in this picture is not a stable, lasting object at all. It is a match struck in a hurricane, snuffed almost the instant it flares. Even if the universe somehow made one, the universe would destroy it, using nothing more than the ordinary thin drift of matter that fills all of space. So now we have two walls, and they stand together, and it is worth holding both in your mind at once, because they attack the white hole from two different directions. The first wall, the second law of thermodynamics, says the white hole should not form in the first place, because forming one would mean running time backward, letting disorder decrease, and the universe strongly refuses to do that. And the second wall, Eardley's instability, says that even if one somehow did form, in defiance of the first wall, it could not survive its own first instant, because the ordinary matter of the cosmos would immediately choke it and collapse it into a black hole. One wall guards the door of birth. The other guards the door of survival. And between the two of them, they explain, as well as anything can, why the sky is so full of black holes and so utterly empty of their mirror twins. This is, I think, the honest heart of the answer to our question. Why does the universe refuse to build a thing its own equations allow? Because the equations of gravity are only part of the story. They tell you what shapes are geometrically possible, but they do not tell you which shapes the universe will actually choose to make, and for that you need the deeper laws, the law of disorder and the fact of instability, and those laws, together, point the arrow of time firmly in one direction and knock the white hole down, whether it tries to be born or merely tries to last. The white hole is not impossible in the narrow sense. It is disfavored, unstable, and swimming against the deepest current in all of nature, the current that carries everything from order toward disorder, from past toward future, from the whole glass toward the shards. And yet, even now, even with both walls standing, the white hole will not quite die, and this is where the story takes a turn that I find genuinely thrilling, in the quiet way that great ideas are thrilling. Because there is a place where the black hole and the white hole seem to blur into each other, a place at the very edge of our understanding, where the neat line between the trap and the fountain grows faint and uncertain. And to reach that place we have to return to Stephen Hawking and to one of the strangest things he ever discovered, a discovery that suggested black holes are not quite as eternal and not quite as one-way as everyone had believed. For a long time, everyone assumed that a black hole was truly, absolutely forever. Things could fall in. Nothing could come out. So a black hole could only ever grow, or at best stay the same. It was the perfect trap, the ultimate drain, eternal and one-directional. But in the 1970s, Stephen Hawking, working through the strange mathematics of the very small applied to the edge of a black hole, found something no one expected. He found that a black hole is not perfectly black after all. It glows. Very, very faintly at the temperature of the horizon itself, a black hole leaks a whisper of radiation out into space. We call it Hawking radiation now, and it is one of the most celebrated results in all of theoretical physics, even though it is so faint we have never been able to detect it from a real black hole, and may never be able to. And here is what that faint glow means over the long, long run. If a black hole is leaking energy ever so slowly, then it is losing mass ever so slowly. And if it is losing mass, then it is shrinking. And if it is shrinking, then it is not eternal after all. Given enough time, an unimaginable stretch of time, far longer than the current age of the universe, longer than almost any number you could name, a black hole will radiate itself away entirely. It will grow smaller and smaller, and as it shrinks it glows hotter and faster, until at the very end it flares away and is simply gone. The perfect trap, the eternal drain, turns out to have a slow leak, and over enough eons it empties itself completely and vanishes. Black holes, it turns out, can die. And this is where the white hole creeps quietly back into the picture in the most unexpected way. 'Cause think about what an evaporating black hole is doing in its final moments. It is a place from which energy is streaming outward. It is shrinking, pouring its contents back into the universe, growing smaller as it gives its mass away. And a place from which things stream out, a horizon that is shrinking as it releases what was inside, begins to sound, does it not, a great deal like a white hole. Some physicists have pointed out that the very late stage of an evaporating black hole is, in certain descriptions, hard to cleanly distinguish from a white hole. The two, which we drew all night as perfect opposites, the trap and the fountain, may blur together at the very edges, at the very end, in the dim and strange final chapter of a black hole's long life. I do not want to overstate this, and honesty holds me back from making it more than it is. This blurring is subtle and debated, and it lives in the deep and uncertain waters where our theory of gravity meets our theory of the very small, two theories that we have never fully joined together. But I want you to sit with the strangeness of it, because it is a lovely strangeness to rest in. We began the night with two perfect opposites, the black hole and the white hole, the door that opens only in and the door that opens only out. And now, at the frontier, we find that the opposites may curl around and touch. That a black hole, given enough time, may end its life looking like the very thing it was supposed to be the opposite of. The mirror and the thing it reflects, reaching toward each other across the longest stretch of time imaginable, and very nearly meeting. There is a wholeness in that, a closing of a circle, and it points us toward the boldest idea of all, the idea that the white hole is not dead, but merely waiting, hidden inside the black hole's own future, ready to emerge. So let us follow that thread next, out to the very edge of what anyone knows, and see how a few daring scientists are trying, right now, to bring the fountain back to life. Before we go out to the very frontier, though, I want to circle back to the grandest version of the white hole idea, the biggest one anyone has ever floated, because it has surely crossed your mind by now, half-formed, and it deserves to be said plainly and then handled honestly. Here is the thought. If a white hole is a place from which matter and light come pouring out of nowhere, streaming outward into space where a moment before there was nothing, then is there not one event in all of history that fits that description perfectly? One moment when everything came pouring out of a single point, spreading outward, filling the void with matter and light, was the beginning of the universe itself, the Big Bang, in some sense the ultimate white hole. It is a natural thought and a beautiful one, and I understand completely why people reach for it. About 13.8 billion years ago, according to our best understanding, everything that now exists, all the matter and energy in all the galaxies in all the sky, was gathered into an unimaginably small, unimaginably hot, unimaginably dense state. And then it began to expand, to pour outward, to spread and cool and unfold into the vast and structured cosmos we live in now. Everything came from that single beginning. All of it streamed outward from what was, in a sense, a single point. And a fountain of matter and light streaming outward from a point is exactly the picture we have been painting all night of a white hole. So the comparison writes itself. The Big Bang as the first and greatest white hole, the mother of all fountains, the door through which the entire universe came pouring out. And I have to tell you, gently but clearly, that this is a picture and not a mechanism. It is a poetic resemblance, a way of holding the idea in your mind, and it is not the standard scientific account of how the universe began. This is one of those places where honesty matters most, because the comparison is so appealing that it can quietly harden into a belief, and I do not want to hand you a belief dressed up as a fact. The standard model of the Big Bang, the one built up over decades from an enormous body of evidence, is not literally a white hole. There are real and important differences, and I will name the heart of one of them. A white hole, as we have described it all night, is a local thing. It is an object sitting somewhere in space, with an outside and an inside, with a horizon you could in principle approach from a distance, with a here and a there, a nearby and a far away. The Big Bang was not like. The Big Bang did not happen at a point inside a pre-existing space with empty room all around it into which the matter then spread. As best we understand it, the Big Bang happened everywhere at once because space itself was part of what was expanding. There was no outside to it, no surrounding emptiness, no place you could have stood to watch it from a distance. It was not an explosion in space. It was an expansion of space, of everything, all at once, with no edge and no center and no outside. And that is a genuinely different kind of thing from a white hole sitting in the sky, a fountain in the middle of a larger cosmos. So most cosmologists, the scientists who study the origin and shape of the universe, treat the Big Bang as white hole idea as a resemblance and not an identity. As a helpful image, perhaps, a way to feel the strangeness of a beginning from which everything poured. Not as the actual machinery. The universe did not, in the standard account, come pouring out of a white hole sitting somewhere. The universe came into being together with space and time themselves, expanding everywhere at once, and the resemblance to a white hole, while lovely, is only skin deep. I say this not to spoil the picture, but to keep us honest, because the whole piece of tonight rests on our willingness to say plainly what we know, what we suspect, and what we have merely imagined. And the Big Bang as a white hole belongs firmly, honestly, in that last basket. A resemblance. Not the standard model, and not a mechanism anyone can point to. But now, having set the grandest and shakiest version gently aside, let me take you to the frontier, to the place where the white hole is genuinely, seriously alive again in the minds of working physicists, not as a picture, but as a live proposal being worked out in careful mathematics right now, in our own time. Because the story I have told you tonight, the story of the two walls, the second law, and the instability, is the story of classical physics, of general relativity and thermodynamics as we have understood them for a century. And there is a place where that century-old understanding is known to break down, where we know our theories are incomplete, and it is exactly the place where the white hole might be hiding, waiting to be reborn. That place is the very center of a black hole. When you follow general relativity all the way down into the heart of a black hole, past the horizon, down toward the middle, the mathematics does something alarming. It predicts a point of infinite density, a place where everything that fell in is crushed down to no size at all, and the density climbs to infinity. We call this a singularity, and it is not really an answer. It is the sound of a theory failing. When your equations start handing you infinities, it almost always means you have pushed them past the edge of where they work, into a place they were never built to describe. General relativity, our magnificent theory of gravity, simply stops making sense at the center of a black hole. Tells us there is a singularity there, and in the same breath it tells us it cannot describe what a singularity really is. Something deeper is needed. And we have a good idea of what kind of deeper thing is needed. It is a marriage of two great theories that we have never fully managed to join, the theory of gravity, general relativity, which rules the very large, the stars and galaxies and the shape of space itself, and the theory of the very small, quantum mechanics, which rules the world of atoms and particles, where things are grainy and uncertain and probabilistic. These two theories are each spectacularly successful in their own domain, and they refuse to fit together. Everywhere in the ordinary universe we can keep them apart, use one for the big and one for the small, and never make them talk. But at the center of a black hole, the very large and the very small are forced into the same tiny room. All the mass of a dead star, crushed down to a size smaller than an atom. There, and perhaps only there, we truly need a theory of quantum gravity, a theory that joins the two, and we do not yet have a finished one. We have candidates. We have careful, serious, unproven attempts. And one of those attempts is where the white hole comes roaring back to life. The attempt is called loop quantum gravity, and it is one of the leading efforts to describe what happens when gravity meets the quantum world. I will not pretend to walk you through its mathematics, which is formidable, but I can tell you the beautiful thing it suggests about the center of a black hole. In loop quantum gravity, space itself is not smooth and infinitely divisible. It is grainy, made of tiny indivisible pieces, of finest possible grain below which you cannot go, the way a beach that looks smooth from far away is really made of separate grains of sand up close. And if space has a smallest grain, then you cannot crush matter down to a point of zero size and infinite density, because there is no zero size. There is a smallest possible size, a densest possible state, and no further. The singularity, the point of infinite density that general relativity predicted, simply cannot happen. Something stops the collapse before it reaches infinity. And what happens when a collapse is stopped before it reaches the bottom? Think of a ball thrown down hard against the floor. It does not keep going down forever. It stops and it bounces and it comes back up. Two physicists in particular, named Carlo Rovelli and Haggard, took this idea seriously and worked out its consequences, and what they proposed is breathtaking. They suggested that a black hole might not end in a singularity at all. Instead, the matter falling in would collapse down and down until it reached that densest possible state, the smallest grain, and then, unable to be crushed any further, it would bounce. And the bounce would turn the black hole, over an immense stretch of time, into a white hole, which would then release back out into the universe everything it had once swallowed. The trap becomes the fountain. The door that opened inward, having reached the bottom, opens outward at last. The black hole, at the end of its unimaginably long life, becomes the very thing we spend all night calling its opposite. They gave the densest state at the heart of this bounce a lovely name. They called it a Planck star, after the smallest scales in physics, the scales named for the physicist Max Planck. Planck star is the tiny, unimaginably dense core at the moment of the bounce, the turning point where falling in becomes pouring out, where the black hole reaches the bottom and starts, slowly, to become a white hole. And so, in this picture, the white hole is not a separate object that the universe refuses to build. It is a stage in the life of a black hole, a chapter that comes at the very end, after the long, slow evaporation, when the object finally reaches its densest heart and rebounds. The fountain was hiding inside the trap all along, waiting at the bottom, on the far side of the deepest fall. I find this one of the most hopeful and beautiful ideas at the whole frontier of physics, and precisely because it is so beautiful, I have to be scrupulously honest with you about exactly what it is and what it is not. So let me say it as plainly as I can. This black hole to white hole bounce, this Planck star, this whole picture, is a frontier proposal. It is serious. It is worked out in careful mathematics by respected physicists. It is not fringe, not crackpot, not a fantasy. But it is also unproven, untested, and far from settled. It rests on loop quantum gravity, which is itself one candidate theory of quantum gravity among several, none of which has yet been confirmed by any experiment. No one has ever observed such a bounce. No one has ever seen a Planck star. Time such a transformation would take, in most versions, is so staggeringly long that we could not hope to catch a large black hole doing it. It is a possibility being explored at the very edge of what we can calculate, and it may be decades, or far longer, before there is any way to test it at all. It is a live idea, not a proven one, and the difference between those two things is the difference between honesty and wishful thinking. There is even a gentle, tantalizing thread that connects this frontier idea back to one of the great unsolved mysteries of the whole cosmos, and I will mention it lightly, marked clearly as the speculation it is. Some of the physicists working on these black hole to white hole remnants have wondered whether the tiny, long-lived leftovers of this process, the small white hole remnants that might linger after the bounce, could make up some part of the dark matter that we know is out there. Dark matter is the name we give to a vast amount of unseen stuff in the universe, matter that we cannot see because it gives off no light, but whose gravity we can feel, tugging on galaxies, bending the paths of stars, shaping the whole cosmos, and which we have never been able to identify. It is one of the deepest open questions in all of science. And a few researchers have raised the possibility, carefully and speculatively, that these little white hole remnants scattered through space, invisible and dense, and left over from the deaths of ancient black holes, might be a piece of that puzzle. I offer that to you not as an answer, but as a wonder, a thread at the very edge of the map, marked plainly, "Here be speculation." It is the kind of idea that shows you the frontier is alive, that the white hole is not a closed case in a dusty book, but an open question that serious people are still turning over, right now, tonight, while you drift towards sleep. So where does all of this leave us? We have followed the white hole from the clean, eternal mathematics, where it is a perfect and untroubled solution, down through the two great walls that keep it out of the real world, and out again to the far frontier, where it may yet return, reborn at the end of a black hole's long life. And through all of it, one thread has run underneath everything, quiet but constant. The thread that I think is the real gift of this whole long question. It is the thread of time, of why the future is different from the past, of why the universe has a direction. And it is to that thread, at last, that I want to turn as we begin the slow drift down toward rest. Let me gather up softly everything we have found and lay it out plainly, the way you might lay out the pieces of a day before you sleep, sorting what was real from what was hoped, what was known from what was merely dreamed. 'Cause the honest shape of what we know is, itself, the most restful thing I can offer you, and I want none of it to slip past dressed up as more than it is. Here is what is true. No white hole has ever been observed. Not one. Not felt in the ripples of space, the way we felt the black holes collide. Not photographed the way we photograph the shadows at the hearts of galaxies. Detected by any instrument, in any way, anywhere in the entire sky, in all the years we have been watching. Every white hole that has ever existed has existed only as a shape in an equation, a possibility on paper, a door drawn in ink. That is not a small thing to admit, and I admit it fully. The fountain that only spills has never once been seen to spill. Here is what else is true. The beautiful, eternal bridge between a black hole and a white hole, the throat that Einstein and Rosen found in 1935, the tunnel to another universe, belongs to the idealized mathematics, to the pristine eternal solution of a whole that was never born and never dies. A real black hole, formed from a real collapsing star, does not build that pristine bridge. The tunnel pinches shut before anything could cross. Perfect bridge is a feature of a perfect object that does not actually exist in nature. Here is what else is true. That strange gamma-ray burst of the June day in 2006, the long flash with no dying star behind it, was proposed by two researchers as a possible white hole, a small bang. But that idea was never accepted. It was a fringe hypothesis, one lonely voice, offered as a maybe and rejected by nearly everyone. It is the closest thing to a white hole sighting we have ever had, and it is almost certainly not one. Here is what else is true. The idea that the Big Bang itself was a giant white hole is a picture, a poetic resemblance, and not the standard scientific account of how the universe began. The Big Bang was an expansion of all of space everywhere at once, not a fountain pouring out into a pre-existing emptiness. Most cosmologists treat the comparison as an image, not a mechanism. And here is what else is true. The black hole to white hole bounce, the Planck star, the idea that a black hole might end its life by turning into a white hole and giving back everything it swallowed, and even the further idea that its tiny remnants might be part of the dark matter, all of this is a live and serious proposal at the frontier of physics, worked out in careful mathematics, but it is unproven, untested, and rests on a theory of quantum gravity that has not itself been confirmed. It is a real idea being seriously explored. It is not a settled fact. Maybe a very long time before anyone can test it at all. That is the honest map of the territory. The equations of gravity allow the white hole freely, and always have since 1915. Nature seems to refuse it, held back by the second law of thermodynamics, which will not let the arrow of time run backward, and by the instability that would choke any white hole into a black hole almost the instant it formed. And no one has closed the case, because the frontier keeps the door ajar, just a crack where quantum gravity might yet let the fountain return. The equations say yes. Nature says, so far. And the honest scientist says, we do not fully know, and that not knowing is not a failure, but a kind of gift, a place where wonder can still live. But I promised you at the very beginning of the night that this question about a door that opens outward was secretly a question about something far larger, about time itself. And I want to make good on that promise now, gently, as we begin to let the hard science soften into something you can carry down into sleep. Think again about why the white hole is so hard for the universe to build. It is not because gravity forbids it. Gravity is perfectly happy to run in either direction. The reason is the arrow of time, the one-way flow of things, the steady growth of disorder that turns whole glasses into shards and never the reverse. The white hole is a thing that would require the film of the universe to run backward, and the universe, as far as we have ever seen, only ever plays its film forward. So the absence of the white hole is not really a fact about a strange missing object. It is a fact about time. It is one of the clearest fingerprints we have ever found of the arrow of time itself. Let me put that another way, because I want it to settle all the way down into you. The universe, in the language of its own gravity, wrote down two possibilities, side by side, equally aloud. The black hole, a place things fall into and never leave. And the white hole, a place things leave and never fall into. Two roads, both legal, both drawn in the same ink by the same hand. And then the universe, quietly, chose one and refused the other. The black hole everywhere, in vast numbers, at the heart of nearly every galaxy. And it declined, apparently, to build even one white hole, anywhere, ever. Of the two roads the equations offered, it took one and left the other untravelled. The white hole is the road not taken. It is a possibility the universe wrote down in its own rulebook, and then, gently and firmly, declined to build. And the reason it declined is the same reason your own life runs the way it does. You remember yesterday, and not tomorrow. You were a child, and you grew, and you will not grow young again. The cup of tea on your table is cooling, not warming. The people you have loved and lost, you carry forward in memory, and time does not run backward to return them. The arrow that forbids the white hole is the very same arrow that carries you and me and everything that has ever lived forward and only forward. From the past we remember toward the future we cannot yet see. The missing white hole in the distant sky and the one-way current of your own small life are, at the deepest level, the same single. To ask why there are no white holes is to ask why there is a difference between remembering and forgetting, between growing older and growing younger, between the glass that shatters and the glass that could never ever mend. There is something I find almost unbearably tender in that, and I want to offer it to you as a comfort rather than a sorrow, because it can be either, and tonight let it be a comfort. The forward flow of time, the arrow that will not reverse, is the very thing that makes a life a life. It is the reason a moment matters, because it comes once and does not come again. It is the reason a memory is precious, because the thing it holds has passed and will not return. If the film could run backward, if the arrow could point both ways, if white holes bloomed everywhere and glasses leapt up whole and the dead grew young, then nothing would ever truly happen, nothing would ever truly matter, because everything could always be undone. It is precisely because time flows one way, precisely because the universe refuses to build the door that opens backward, that your days have weight, that your choices are real. The moment you are in right now, breathing slowly in the dark, is a moment that exists once and is yours alone. So the white hole, that beautiful thing we have never found and may never find, gives us a strange and lovely gift by its very absence. It shows us, by not being there, exactly what time is and why it flows, and why that flowing, which can seem so sad when we think of all we have lost to it, is also the very thing that makes the losing matter, and the having matter, and the being here at all matter. The universe took the forward road, and that forward road is the road of your whole life, every step of it, every breath, carrying you gently onward through the one-way dark. And now, having followed this question all the way from a door standing alone in the night, through the equations of a soldier and the maps of two lone mathematicians, through the naming and the bridge and the two great walls and the far frontier, we have arrived at the place where the hard science gives way, and the mind is allowed, at last, to simply rest. So let us set the equations down now, softly, like a book laid closed on the nightstand, and let us spend the last of our time together not in learning, but in resting, drifting out beyond the numbers and the names, into the quiet wonder of being a small, warm, breathing thing beneath an infinite sky. Let your shoulders loosen. The day you carried finally set itself down. There is nothing left to understand tonight. There is only the vastness and your place within it, and the slow, kind pull of sleep. Let me hold up one more time the image we began with, because it has grown richer now, and there is comfort in returning to something familiar after a long journey. A door, standing alone in the dark. A black hole is a door that only opens inward. However hard you push from the inside, it will never let you leave. And a white hole is that same door, hung backward, a door that only opens outward, and however hard you push from the outside, however gently you try to slip in, it will never let you enter. Hold both of those images together, side by side, in the quiet of your mind. The door that takes and never gives. The door that gives and never takes. And between them, in the space between the taking and the giving, lives the whole mystery of time, the whole reason the world flows the way it does. There is another image I gave you tonight, and I want to return to it too, because it is the softest way I know to hold the deepest idea. Picture a glass falling, shattering on the floor. The shards scatter. And now picture that same moment, run backward, the shards leaping up, rushing together, the glass reassembling itself, whole and perfect, rising back into your hand. A white hole is that reversed film made real. It is the shattered glass gathering itself back together, written into the language of gravity. And the universe, so far as we have ever been able to see, has never once let that film run backward. Not in a kitchen. Not in the heart of a dying star. Not anywhere in all the vast and ancient sky. The film runs forward, always forward, and that forward flow is the arrow that carries you right now softly towards sleep. I want you to feel, for a while, just how large the thing is that you are resting inside of. To frighten you with it, but to let its very vastness become a kind of blanket. Because there is a strange comfort in bigness when you let it be a comfort. The worries of a day are small. Cares that followed you into this room are small. And you are held inside something so immense that the largest of your troubles does not even register against it, and there is a mercy in that, a permission to set things down. Think of the light year, that distance we spoke of, the distance light travels in a single year. Light is the fastest thing there is, moving so quickly that in one heartbeat it could circle the whole earth several times over. And yet even light, at that unthinkable speed, takes a full year to cross a single light year, racing without rest through the dark the entire time. Now consider that the nearest star to our own sun, the very closest neighbor we have in all the cosmos, is more than 4 light years away. That means the light you see from it tonight left it more than 4 years ago and has been traveling towards you without stopping ever since. When you look up at that star, you are not seeing it as it is. You are seeing it as it was years ago, the light only now arriving, a message 4 years in the crossing. And that is only the nearest star. Our own galaxy, the Milky Way, the great wheel of stars we live inside, is so wide that light takes about 100,000 years to cross it from one edge to the other. 100,000 years, at the speed of light, just to span the single galaxy we call home. When the light that is leaving the far side of our galaxy tonight finally reaches the other side, 100,000 years from now, the whole of human history as we know it will be a distant, unimaginable memory, if we are remembered at all. That is the size of our home. Just our home. Just the one galaxy out of hundreds of billions. Because that is the next thing to let settle over you, softly. Our galaxy That wheel 100,000 light years across, holding hundreds of billions of stars, is only one galaxy among hundreds of billions of galaxies scattered across the universe we can see. Number rest on you gently. Hundreds of billions of galaxies, each one holding hundreds of billions of stars. The mind cannot truly hold a number like that. It is not built to. And that is all right. You do not need to hold it. You need only to feel, at the edge of it, the sheer immensity, the way you might feel the size of the ocean standing on a beach at night, unable to see the far shore, hearing only the waves, knowing that it goes on and on beyond anything you could walk. And the light from those distant galaxies has been traveling toward us for millions, and hundreds of millions, and even billions of years. When we photographed the black hole at the heart of that far galaxy, Messier 87, the light in that picture had left it tens of millions of years ago. It began its journey toward us before there was any human being on Earth to receive it. Crossed the dark for longer than our whole species has existed, carrying its faint message, its ring of light and its round shadow, and it arrived at last in our own lifetime to fall into a telescope we had only just learned how to build. Think of that. A message sent tens of millions of years ago, arriving exactly when we had finally become ready to read it. There is a kind of grace in that timing, a sense of the universe being patient with us, holding its light steady across the eons until we were ready to look. This is the thing I keep returning to, and the thing I most want to leave with you tonight as your breathing slows and the day loosens its hold. You are a small, warm, living thing, resting somewhere on the surface of a small blue world, and that world is turning slowly beneath you, as it always has, carrying you gently through the night. And that world is circling an ordinary star, one of hundreds of billions in our galaxy. And that galaxy is one of hundreds of billions in the visible universe. And around you, woven into the very fabric of the space you rest in, are possibilities so strange that the equations of our greatest theories allow doors that open outward and bridges to other universes and fountains of light pouring from nowhere, even if nature, in its quiet wisdom, seems to have declined to build them. You live inside a cosmos that is stranger and larger and more beautiful than any story anyone has ever told, and you belong to it completely, the way a wave belongs to the ocean, the way a single note belongs to a psalm. And here is the part that I find most comforting of all, and I hope you will too. Your smallness is not a sorrow. Against the size of all that, it can feel, for a moment, as if you hardly matter, as if a single life is nothing at all beside 100 billion galaxies. Turn the thought over, and it softens into something else entirely. You are not separate from all that vastness standing outside it, dwarfed and alone. You are made of it. The atoms in your body, the iron in your blood, the calcium in your bones, the very carbon that makes up so much of you, all of it was forged inside stars long ago, in the hearts of suns that lived and died before our own was ever born. When those ancient stars ended their lives, they scattered the elements they had made out into space, And from that scattered dust, in time, new stars and new worlds, and eventually you were assembled. You were not a stranger in the cosmos, looking up at it from outside. You are the cosmos, gathered for a little while into a shape that can look up and wonder at itself. The universe made you out of its own ancient stars and gave you eyes, and here you are, resting in the dark, thinking of white holes and the arrow of time, a small piece of the universe come briefly awake, marveling at the whole. There is no smallness in that. There is only belonging. So let that belonging hold you now, the way the vastness holds every star. Let your breathing slow. The great size of things, which might have frightened you once, become instead the softest and largest of blankets, tucked in on every side by galaxies you will never see, warmed by the light of suns that died before you were born. You are held. You have always been held. And there is nothing you need to do tonight but rest inside that holding and let the slow turning of the world carry you down, gently into sleep. There is a phrase I used earlier tonight, and I would like to return to it now, slowly, because it holds more comfort than it first appears to. I called the white hole the road not taken. Of all the shapes that the equations of general relativity permit, of all the doors that the mathematics of gravity leave standing open, the white hole is the one that reality seems to have quietly refused to build. A possibility the universe wrote down in its own rulebook, in its own hand, and then declined to make real. And I want you to sit with how gentle that refusal is. The universe did not tear the page out, did not erase the equation. The white hole is still there, still allowed, still perfectly legal in the language of gravity, right where Einstein and Schwarzschild and Kruskal and Szekeres left it. The universe simply chose over and over not to walk down that particular road. It left it there, drawn and open and untravelled, like a path through a wood that no one ever takes, still there, still real, simply unwalked. And the reason it left that road untravelled is the same reason your own path through time runs the way it does. And I keep returning to this because it is, to me, the deepest and softest truth of the whole night. The universe took the forward road. It chose the direction in which glasses shatter and never mend, in which ink spreads and never gathers, in which the warm cup cools into the room and the room never pours its warmth back into the cup. It chose the direction of memory, of aging, of things happening once and not again. And that forward road, that single chosen direction, is the road your life is walking, this very moment, with every slow breath you take in the dark. Now here is the thought I want to give you to rest on. It might seem at first that the forward road is the sadder one, that a universe where time could run backward, where white holes bloomed and the lost could return and every broken thing could mend itself, would be kinder than the one we have. Turn it over gently, the way you would turn a stone in your hand to catch the light, and you will find it is the other way around. It is precisely because time runs one way, precisely because the universe refused the white hole and took the forward road, that anything means anything at all. A moment matters because it comes once, A day is precious because it will not return. People you love more because your time with them flows forward and does not loop. If the film could run either way, if nothing were ever final, then nothing would ever truly be. It is the one-way flow, the very thing that forbids the white hole, that gives weight to every hour of your life, that makes this quiet moment right now real and singular and yours. So the missing white hole, that thing we have searched for and never found, that beautiful absence in the sky, is secretly a gift. It is the shape of the reason your life is real. It is the fingerprint of the arrow that carries you and me and everyone who has ever lived forward through the one-way dark, giving each of our small moments the weight of happening only once. When you understand why there are no white holes, you understand why your own life matters, why it flows, why it cannot be undone, and why that unrepeatability, which can feel like loss, is also the very thing that makes it precious. There is no sorrow in it once you turn it fully to the light. There is only the quiet dignity of a life that happens forward once and is real. Let me give you a few more images of the thing, softly, because restatement is a kind of comfort, the way a familiar lullaby comforts not by telling you something new, but by returning, again and again, to something known. Think of a fountain in the middle of empty space. Not a fountain fed by any pipe, not a fountain drawing water up from any pool. Just a point in the empty dark with nothing around it, no star, no cloud, no engine of any kind, and then, without warning, a spray of light and matter pouring out of it, streaming outward into the night, and nothing, no matter how it tried, able to fall back in. That is the white hole, the fountain from nowhere, the spill without a source. And the universe, so far as we can tell, has never built one. Every fountain we have ever found has a source. Every spill of light has an engine behind it. The sourceless fountain remains a shape in the equations and nothing more, and there is a strange peace in that, in a universe that keeps its accounts so carefully, never lets something pour out of nothing, that always has a reason behind the light. And think, once more, of the thing hidden in plain sight, because I love this image most of all. The white hole was folded up inside the black hole's own equations for more than 40 years before anyone unfolded the map completely enough to see it. It was there in Schwarzschild's wartime solution from the very beginning, waiting, patient, unnoticed. The answer was inside the question the whole time. And I think there is a lesson in that which reaches far beyond physics, a lesson worth carrying down into sleep. So much of what we search for is not far away at all. So much of what we long to understand is already in our hands, folded up inside something we thought we already knew, waiting only for us to look a little more carefully, a little more patiently, a little more kindly. The white hole did not come from a distant telescope. It came from looking, at last, all the way into something we already had. And perhaps the same is true of the peace you are looking for tonight. Perhaps it is not far away either. Perhaps it is already here, folded up inside this quiet moment, waiting only for you to stop searching and simply rest. You're breathing slow now, a little more. There is nothing left to solve. The great question we set out with, what is a white hole and why has the universe refused to build one, we have followed all the way to its honest end. And the end is not a hard answer, but a soft one. The equations allow it. Nature seems to decline it. The arrow of time forbids it, and that same arrow is the thing that makes your life real, and no one has fully closed the case, and there is wonder still living in the not knowing. That is enough. That is more than enough. You do not have to hold any of it now. You can let it all drift away, the equations and the names and the numbers, the way you let a day drift away as you fall asleep, keeping only the warmth of it, the sense of having wondered at something vast and beautiful, and being held still inside it. Let me stay here with you a while longer, in this soft place beyond the science, and simply let the largeness of things settle over you like the deepening of the night. There is nowhere to be. There is nothing to finish. The great wheel of the galaxy turns, as it has turned for billions of years, and will keep turning long after this night is forgotten, and you are a part of that turning, carried gently along, a small warm point of wonder in an ancient and enormous dark. Rest there. Let it hold you. The vastness be a blanket and not a burden. And let us drift together a little further down towards sleep. Let me walk back through where we have been tonight, slowly and softly, the way you might retrace a long and gentle path at the end of a day, not to learn it again, but simply to feel the shape of the journey before you let it go. There is comfort in retracing. Let the familiar landmarks pass by once more, dimmer now, softer now, as your eyes grow heavy. We began with a door standing alone in the dark, a door that only opens one way. We saw that a black hole is that door opening inward, a place you can fall into and never leave. And we hung that same door backward and found the white hole, a place you can leave but never enter, the fountain that only spills. Two halves of one strange coin. One that takes and never gives. One that gives and never takes. We learned that the white hole is not a fantasy, but a real solution to Einstein's equations of gravity, published in 1915, a theory tested for more than 100 years and never yet found wanting. The white hole falls out of the mathematics on its own, the way a shadow falls from a shape. If black holes are allowed, then white holes are allowed too, by the deep symmetry of the equations, which do not care which way time flows. We travelled back to the winter of the First World War, to a soldier named Schwarzschild, doing mathematics on a battlefield, solving Einstein's fearsome equations for the simplest case, a single round mass sitting alone in space. He found the first description of a black hole and sent it to Einstein, and then he died, never knowing what his few pages would one day reveal. We watched, more than 40 years later, as two mathematicians working an ocean apart, Martin Kruskal and George Szekeres, read Schwarzschild's map in the year 1960 and found that it was far bigger than anyone had known. not one region, but four. Our universe. The black hole's interior. A mirror universe on the far side. And, hidden in plain sight all along, the white hole, the black hole's time-reversed twin, folded up inside its own equations, waiting to be unfolded. We gave the white hole its name from Igor Novikov and that era of the middle 1960s, the same decade that named the black hole too, the two mirror ideas christened almost together. And we walked out onto the Einstein-Rosen bridge of 1935, the throat connecting a black hole to a white hole, the distant ancestor of every wormhole in every story, and we learned, honestly, that this eternal bridge belongs to the idealized mathematics, and that a real collapsing star does not build it, because the throat pinches shut before anything could cross. We stood inside the great gap. Black holes, felt through the ripples of their collisions in 2015, photographed at the heart of a distant galaxy in 2019, photographed at the heart of our own galaxy in 2022. Confirmed, reconfirmed everywhere we look. And white holes, their perfect twins, never once seen. Felt. Photographed. Not detected in any way, anywhere, ever. Two ideas, equally allowed by the mathematics. One everywhere. One nowhere. We told the story of the one candidate that wasn't, the strange gamma-ray burst of the June day in 2006, a long flash of about 102 seconds with no dying star behind it, proposed by two researchers as a possible white hole, a small bang, and never accepted, a lonely maybe at the far edge of the conversation, almost certainly not a white hole at all, but the closest the sky has ever come to offering us one. We walked slowly through how we read the sky at all. How we cannot look for what falls into a white hole, because nothing can, so we must watch for what pours out, a fountain from nowhere with no source to feed it. How we spread a beam of light apart to read the fingerprints of the elements that made it, the art of spectroscopy. How the stretching of that light, its redshift, tells us how far away a thing is, and how long ago its light began its journey. How the shape of a sudden flash, its light curve, its heartbeat, tells us what kind of engine drove it. And how, every time, we must rule out every ordinary explanation before we may whisper the word extraordinary, which is why no white hole has ever been confirmed, not for lack of looking, but because the bar of proof is so very high. And then we came to the two great walls. The second law of thermodynamics, the law of the shattering glass and the spreading ink and the cooling tea, the law that says disorder always grows and never shrinks on its own, the law that carries the arrow of time. A white hole would run that arrow backward, pulling order out of chaos, and the universe strongly refuses to do that. And the wall of instability, found by Douglas Airdley in 1974, which showed that even a white hole that somehow formed would be choked, almost at once, by the thin drift of ordinary matter that fills all of space, piling up at its door, collapsing it, turning the fountain into a trap, the white hole into a black hole. You walls, one guarding the door of birth, one guarding the door of survival. And then, at the very frontier, we found that the white hole will not quite die. We followed Stephen Hawking's discovery that black holes glow ever so faintly and slowly evaporate, so that even they are not truly eternal. And we saw how the dim final stage of an evaporating black hole begins to blur into something white hole-like, the opposites reaching toward each other across the longest stretch of time. We heard the bold proposal of Carlo Rovelli and Haggard that a black hole might not end in a singularity at all, but bounce through a densest possible state they called a Planck star and turn, over an immense age, into a white hole that gives back everything it swallowed. And we marked it clearly as what it is, a serious, careful, unproven idea at the very edge of what anyone can calculate, resting on a theory of quantum gravity we have not yet confirmed. And under all of it, one thread ran quietly, the thread of time. The reason the white hole is so hard for the universe to build is not gravity, which allows it freely, but the arrow of time, the one-way flow of things, the same arrow that carries you from the past. You remember toward the future you cannot see. The absence of the white hole is a fingerprint of that arrow. And the arrow that forbids the fountain is the very same arrow that gives your life its weight, that makes each moment happen once and matter because it happens once. That is the whole journey, laid out gently, one landmark after another, growing dimmer now as we pass them by. You do not have to hold any of it. Let it go, the way you let a day go as you fall asleep. Keep only the warmth. Keep only the sense of having wondered at something vast and beautiful, and of being, yourself, a small and welcome part of it. The names and the numbers can drift away now into the dark. They have done their work. They carried us here, to this quiet place, and here we can set them down and rest. Let me give the vastness to you once more, in fresh images, because the size of things is the softest blanket I know, and there is no hurry now, nowhere to be, nothing to reach. Let the numbers wash over you slowly, not as facts to hold, but as waves to be carried by. Imagine the light that is falling on you tonight from the distant stars. Some of it is old, older than you can easily feel. When you look up at certain stars, the light entering your eyes left them before you were born, crossed the dark for the whole of your life, and is only now, this night, arriving. Look a little farther, at the faint smudge of a distant galaxy, and the light you catch from it may have left before there were human beings at all, before there was anyone anywhere to look up and wonder. Some of the light in our great telescopes left its source when the first simple life was only just stirring in the seas of our young world. To look out into space is to look back into time. The sky is not a picture of now. It is a vast, layered memory, near stars showing us a few years past, far galaxies showing us the deep and ancient past, all their different ages gathered together in the same quiet field of view above you. If it helps, the light that left a certain distant place when the great dinosaurs still walked the earth, tens of millions of years ago, And think of it travelling all that time, patient and unhurried, through the empty dark, past star after star, across gulf after gulf, while whole ages rose and fell on our small world, while the dinosaurs vanished, and the mammals rose, and the mountains wore down and new ones lifted, while our own kind appeared and learned to speak and build and wonder, and only now, tonight, at the very end of that unimaginable journey, does that ancient light arrive and fall softly into a telescope we built, or into your own upturned eye. The light is a messenger from a world so long ago that the messenger itself is older than nearly everything you have ever known. And it arrives, gently. Let me try the scale another way, because there are as many ways to hold it as there are stars, and each one is a fresh comfort. Think of our own sun, that enormous burning sphere, so large that more than 1,000,000 Earths could fit inside it. It is, to us, unthinkably vast, and yet it is an ordinary star, middling in size, one of the countless suns that fill our galaxy, and far from the largest. There are stars out there so enormous that if you placed one where our sun sits, it would swallow the orbits of the inner worlds entirely, its surface swelling out past where the Earth now travels. And then remember that even the very largest star is a mote, a speck, against the size of the galaxy that holds it, and the galaxy a speck against the size of the universe that holds it. Layer upon layer of bigness, each one dwarfing the last, out and out and out, farther than the mind can follow, farther than light itself can travel in the whole age of the cosmos. And somewhere in all of that, woven into the very fabric of the space around you, are the strange doors we have spoken of tonight. Real black holes, felt and photographed, sitting at the hearts of galaxies, anchoring whole wheels of billions of stars with their silent, tremendous pull. And the possibility, allowed by the same equations, of their mirror twins, the white holes, the fountains that only spill, doors that open outward, which nature seems to have declined to build, but which linger in the mathematics still, quiet possibilities, roads not taken, drawn and open and untravelled in the deep grammar of the universe you rest inside. You live in a cosmos where such things are even possible to write down, where the equations of gravity, followed honestly, hand you tunnels to other universes and fountains of light from nowhere and doors that open only outward, whether or not nature ever builds them. You live in a place stranger and larger and more wondrous than any tale anyone has ever told around any fire, and you belong to it, wholly and without question, the way the wave belongs to the sea. That is not a small thing to be. That is not a small place to live. And there is nothing you need to do about it tonight, but let it hold you. Because here is the gentlest truth of all, the one I most want to leave with you as your thoughts begin to soften and blur. You are not a visitor to this vast universe, peering in from somewhere outside, small and alone against its immensity. You are made of it. Every atom in your body was made inside a star. The iron that reddens your blood, the calcium that holds up your bones, the carbon threaded through every living part of you, all of it was forged in the hot hearts of stars that lived and died long ago, before the sun was born, before the Earth existed. Those ancient stars burned through their lives and then, in their dying, scattered the elements they had made out into the dark. And from that scattered ash, over unimaginable stretches of time, new stars gathered, and new worlds, and at last, on one small blue world, you. The stuff of you is star stuff, ancient beyond measure, borrowed for a little while, and shaped into something that can breathe and think and wonder at the very sky it came from. So when you look up at the stars, you are not a stranger looking at something foreign. You are one part of the universe looking at another part, kin greeting kin, the cosmos regarding itself through the eyes of one small, warm creature it made from its own long-dead suns. There is no distance in that, not really. There is only family. You are the universe grown briefly aware, gathered for a short and precious while into a shape that can love and remember and rest. And when at last you sleep, you do not leave the cosmos. You settle deeper into it, a small part of the whole, carried gently onward by the same forward flow of time that carries every star, every galaxy, every ancient beam of light still crossing the dark towards some far shore it will not reach for 100 million years. Let that carry you now. The bigness be tender. Let the ancient light and the burning suns and the silent doors in the dark all soften into a single feeling, the feeling of being held and small and welcome and made of the very thing that holds you. There is nowhere you need to go. There is nothing you need to be. You are already home and have always been, resting in the middle of the vast and gentle dark that made you. There was a dream woven through our story tonight, quiet and old, and I want to hold it up gently before we finish, because it is a dream that lives in almost everyone, and there is comfort in seeing it clearly. It was the dream of the bridge. Einstein and Rosen bridge, the throat that joins a black hole to a white hole, the tunnel that might carry what falls in here to some far elsewhere, another place, another time, another universe entirely. The wormhole, the door to somewhere else. It is one of the most seductive ideas anyone has ever written down, and I think its pull is deeper than physics. Because who has not, at some tired moment, wished for a door to somewhere else? A shortcut out of a hard day, a tunnel away from a heavy season, a passage to another life on the far side of the dark. The wormhole is that wish made mathematical, the longing for an elsewhere written into the geometry of space itself. And when Einstein and Rosen found that throat in their equations in 1935, it must have felt, for a moment, as though the universe were offering us exactly that, a real door to a real elsewhere. But we learned tonight, honestly, that the door does not open the way the dream hopes. The eternal bridge belongs to the idealized mathematics, to the perfect black hole that was never born and never dies. A real collapsing star does not build a crossable tunnel. The throat pinches shut before anything could pass through it. The passage to elsewhere, in the real universe, closes itself every single time. And I do not think that is a sadness once you sit with it. I think it is a quiet kindness. Because here is what the closing of the bridge is really telling you. There is no shortcut out of here. There is no tunnel away from your life into some other, easier one on the far side of the dark. And that means gently that here is where you are meant to be. This world, this night, this small warm body breathing in the quiet, this one forward-flowing life is not a waiting room for some elsewhere you might tunnel away to. It is the thing itself. It is where you belong. The universe closed the doors to elsewhere over and over in every collapsing star, and in doing so it left you fully, completely at home right here in the only place there is, place that made you and holds you. And when you stop wishing for the door to somewhere else, something softens. The longing to escape, which is so much heavier than we notice, can set itself down. There is nowhere else to get to. There is no bridge to cross, no tunnel to find, no far shore you are failing to reach. There is only here, only now, only this quiet moment beneath the same stars that have always been there, and the slow forward flow of time carrying you gently through it. You are not missing the door. There is no door to miss. You are already exactly where you belong, and you always have been, and you can rest in that completely. So let the dream of the bridge drift away now, along with everything else, and let its going be a relief rather than a loss. You do not need a tunnel to elsewhere. You have this, the vast and gentle dark, the ancient light, the turning world, the slow tide of your breath, and your own small welcome place in the middle of it all. That is not a lesser thing than a wormhole to another universe. It is a greater thing because it is real, and it is yours, and it asks nothing of you but that you rest inside it. The door to elsewhere close softly one last time, and let the here and the now open all the way and hold you and carry you down towards sleep. I want to return one last time to the two doors and set them gently side by side in your mind, because they have become, over this long night, something more than physics. They have become a way of feeling the shape of time itself, and I think there is a deep peace in holding them together as you drift. On the one side, the black hole, the door that opens inward. Everything it touches, it draws toward itself and keeps. It is the direction things fall. It is where order goes to become disorder, where the intricate arrangements of matter are swallowed and the horizon grows a little wider with each thing it takes. The black hole is the future, in a sense, the destination, the place the arrow of time points toward. It is real, and it is everywhere, at the heart of nearly every galaxy in the sky, silent and patient and vast. And on the other side, the white hole, the door that opens outward. Everything it holds, it gives away and never takes back. It is the direction things would have to come from, the source, the fountain. The place order would spill out of chaos, and the horizon would shrink as it poured. The white hole is the past, in a sense, the origin, the place the arrow of time would point away from. and it is not there. It is the one the universe declined to build. It is the road not taken, still drawn in the equations, still open, still legal, and still, so far as we have ever seen, entirely empty. And between those two doors, between the one that only takes and the one that only gives, runs the single arrow of time, the one-way flow that makes the black hole common and the white hole absent. The universe keeps its doors in careful order. It lets things fall in and does not let them fall out. It lets the glass shatter and not mend, the ink spread and not gather, the warm cup cool and not rewarm. Keeps its accounts with a steady, unbroken honesty, never letting order appear from nowhere, never letting the film run backward, never once building the door that would break the rule. There is something trustworthy in that, something you can lean your whole weight against. The universe does not cheat, does not run backward, does not undo. It flows forward, always forward, with a constancy older than the stars, and that constancy is the very ground beneath your life. And I find, when I sit with it long enough, that this is a comfort and not a sorrow. We spend so much of our lives wishing, quietly, that we could run the film backward, that we could return to a moment before a loss, before a mistake, before a goodbye, that we could gather the shards of some broken thing and knit it whole again. The white hole is, in a way, that wish written into the language of gravity, the wish that time could reverse, that what was given up could be taken back, the fountain could pour the past back into the present. And the universe, gently and firmly, says no. It will not build that door. Time flows one way. But look what the forward flow gives you in return for what it takes. It gives you the reality of every moment you have. Because time does not loop back, this night is truly happening, once, and is truly yours. Because the arrow points forward, the love you have known was real, is real, cannot be unmade, is woven permanently into the fabric of what has been and can never be taken back out of it. Nothing that has truly happened can ever unhappen. The forward flow that forbids the white hole is the same flow that makes your past permanent, safe, indelible, kept forever in the great honest ledger of what was. Cannot return to it, no. But neither can it ever be erased. It happened, and because time flows only forward, it will always, always have happened. There is a kind of eternity in that, a gentler eternity than the one the white hole offered. The eternity of undoing, but the eternity of having been. So let the day you carried settle now into that safe, permanent past. Whatever it held, whatever weight, whatever small victory or quiet ache, it is done now, and it is kept, and it cannot be taken from you, and it also cannot follow you into sleep unless you let it. You can set it down. The universe has already filed it away, gently, in the ledger of what has been, where it is safe forever. You do not have to hold it any longer tonight. let the arrow of time do what it does best. This day become the past, softly, and let the next moment and the next carry you forward into rest. There is nothing left to understand. The great question is answered as honestly as anyone can answer it, which is to say, partly, with wonder still living in the gaps. The equations allow the white hole. Nature seems to refuse it. Arrow of time forbids it, and that same arrow gives your life its weight and keeps your past forever safe. And no one has closed the case, and that open door of not knowing is not a lack but a gift, a place where the mind can rest without needing to finish anything, a question you are allowed to simply hold, unopened, and carry down into sleep. Feel, now, how your body has grown heavier against whatever holds it, the chair or the bed or the pillow beneath your head. Feel how the small tensions you did not even know you were carrying have begun, on their own, to loosen and let go. There is nowhere to be. There is nothing to finish. The wheel of the galaxy turns slowly, as it has for billions of years, and will for billions more, and you are a part of that turning, carried along without any effort of your own, a small, warm point of quiet in the enormous, gentle dark. You do not have to do anything to belong here. You already belong. You always have. Let that knowledge settle all the way down through you, and let it carry you softly a little further towards sleep. Let us stay here in the soft dark, and let the last of the thinking fall away like a coat slipping from your shoulders. You have wondered enough tonight. You have followed a strange and beautiful question all the way from a soldier's candlelit mathematics to the far frontier of what anyone knows, and you have earned this rest at the end of it. So let the mind go quiet now. Let the words become a river you no longer have to follow, only float upon, carried gently downstream towards sleep. Notice your breathing without changing it. Just notice it, the slow rise, the slow fall, the quiet turning of air, in and then out, the oldest rhythm there is, older than any language, older than any thought. You have breathed this way every moment of your life, through every day you can remember and every night you have forgotten, and it asks nothing of you now. It simply carries on, faithful, unhurried, in and out, like the tide, like the slow turning of a world. Let each breath out be a little longer than the one before, a little softer, a little more willing to let go. There is nothing to hold on to. There is only the next slow breath, and then the next, carrying you down. Feel the weight of your body now. Truly feel it, the way it presses down into whatever holds you. Feel how the surface beneath you rises up to meet that weight, catching it, holding it, so that you do not have to hold yourself at all. You can let go completely. The bed or the chair will keep you. The floor will keep the bed. The world will keep the floor, turning slowly beneath it all as it always has. There is a whole chain of holding beneath you, all the way down, and you are the small warm thing at the top of it, held by everything below, needing to hold nothing yourself. Let your muscles understand that. Let them loosen one by one as the message reaches them that they are off duty now, that there is nothing left to carry, that the holding is being done for them by the patient world. The loosening begin wherever it wants to. Perhaps in your shoulders, which have carried the day. Let them settle down and back, away from your ears, heavy and warm. The loosening move down your arms, all the way to your hands, until your fingers have no more work to do, until they curl or rest exactly as they fall, asking nothing. Let it move through your chest, softening with each breath out. Let it move down your back, each part of your spine giving its weight to what holds it. Let it flow down through your legs, unhurried, warm, all the tension of standing and walking and holding yourself upright through a long day simply draining away, down and out, until your legs are heavy and still. And let it reach at last all the way to your feet, so that there is not one part of you left holding, not one part still on duty, nothing left but the slow rise and fall of your breath, and the gentle weight of a body fully at rest. And as your body grows heavy and still, let your thoughts grow slow and few. If a thought drifts by, some worry, some fragment of the day, some question left unfinished, do not chase it and do not fight it. Just let it drift on past, the way a cloud drifts across the night sky, there for a moment and then gone, while the stars behind it stay, quiet and constant and unbothered. You are the sky tonight, not the clouds. The thoughts may come and go, but you remain still and dark and wide, holding them gently and letting them pass. There is nothing you must think about now. There is nothing you must solve. The great question of the white hole is answered as well as it can be, and the small questions of the day can wait for morning, and morning will come in its own time, carried to you by the same forward flow of time that carries every star. You need not reach for it. It will arrive on its own. Above you, though you cannot see them from where you rest, the stars are still there, exactly where they have always been, wheeling slowly through the night as the world turns beneath you. The black holes are there too, silent at the hearts of their galaxies, doing what they have always done, holding whole cities of stars in their patient, invisible grip. And the white holes are not there, as they have never been, the fountains that never poured, the doors that never opened, the roads the universe declined to take, still drawn in the quiet equations, still possible, still empty. All of it turns on, vast and ancient and calm, whether you watch it or not, whether you understand it or not, whether you are awake or asleep. It does not need your attention. It only offers itself freely as something to belong to, something to rest inside of, something so much larger than any trouble that the trouble simply cannot follow you all the way out into it. So go out into it now, in your mind, one last gentle time. Rise up, weightless, above the room, above the roof, above the small lights of wherever you are, up into the cool dark where the stars come out one by one. Feel how quiet it is up there, how still, how enormous. Feel how the worries that seem so large down below shrink to nothing against the size of it, not dismissed, not denied, simply held in their true proportion at last, small things beneath an endless sky. and feel, most of all, that you are welcome there. That you are not an intruder in the vastness, but a child of it, made from its own ancient stars, come briefly awake to marvel, and then gently to rest. You belong to the dark between the stars, as surely as the stars do. And it is time now, at last, to let it hold you all the way down into sleep. Before we come all the way to the close, I want to give you one more thing to rest on, and it is not about the white hole at all, not really. It is about the small, soft creatures who spent 100 years chasing it. It is about us. Because when I step back from the whole story, the thing that moves me most is not the strangeness of the doors in the dark. It is that a species as small and as young as ours ever came to know about them at all. Think of what had to happen for you to lie here tonight, wherever you are, and understand that black holes are real and white holes may not be. A man had to sit in the cold and the fear of a battlefield and solve the hardest equations anyone had ever written, by hand, by candlelight, while a war raged around him. Two other minds, an ocean apart, had to stare at those same equations for years until the hidden map unfolded. Others had to invent the very idea of reading a beam of light apart into its fingerprints, and to notice that the light of distant galaxies is stretched, and to work out what that stretching meant. Whole generations had to build ever finer instruments, and to teach one another, and to pass the questions down like a lamp handed from hand to hand across the dark, each person carrying it a little farther before passing it on. And then, in our own lifetimes, thousands of people spread across the whole Earth had to link their telescopes into a single planet-sized eye and feel the faint tremor of two black holes colliding 1 billion years ago, and photograph the shadow of a monster at the heart of our own galaxy. All of that, so that you could lie here tonight and know. That is a kind of miracle when you let yourself feel it. We are small. We live short lives on a small world circling an ordinary star at the quiet edge of one galaxy among hundreds of billions. We are soft and easily hurt, and here for only a little while. And yet, with nothing but our curiosity and our patience and our willingness to hand the lamp forward, we reached out across billions of light years and billions of years and learned the secrets of doors we will never touch, in places we will never go, made of forces we can barely imagine. The light of our understanding travelled outward to meet the light of the stars, and somewhere in the vast dark between, the two met, and we came to know. There is a light in that which I find as beautiful as any star. The light of a creature that refuses to stop wondering. You are made of that light too. The same curiosity that drove a dying soldier to solve Einstein's equations is the curiosity that brought you here tonight, to lie in the dark and wonder about a fountain that pours from nowhere and a door that opens outward. You did not have to wonder about such things. Nothing in your day required it. No survival depended on it. You wondered simply because you are the kind of creature that wonders, because somewhere deep in you there is a small steady flame that turns toward the vast and the strange and the beautiful, and wants, quietly, to understand. That flame is very old. It has been handed down through every generation that ever looked up at the night and asked what all those lights could be. And tonight it lives in you. So let that be a comfort as you drift, the knowledge that you belong not only to the vast physical universe of stars and galaxies and silent doors, but to the long, warm human chain of wonder that has been reaching out toward that universe for as long as there have been people to look up. You are the latest to hold the lamp. And holding it does not mean you must solve anything or finish anything or carry it any particular distance. It means only that you looked and wondered and let yourself be filled for a little while with the strangeness and the beauty of it all. That is enough. That is the whole of it. To have wondered is already to have belonged. And now the wondering can rest. You have looked far enough tonight. You have followed the lamp all the way to the frontier and seen how much is known and how much is still gloriously unknown, and you can set the lamp down now, gently, beside the bed, still glowing, ready to be picked up again another night. It will keep. The questions will keep. The white hole will still be there in the equations tomorrow, still allowed, still absent, still waiting for someone, someday, to understand it fully, or to prove at last that it can never be. That someone does not have to be you, and it does not have to be tonight. Tonight you have done the loveliest part already. You wondered, and now you rest. Let the vastness hold you, and let the long chain of wanderers hold you too. All the small bright minds across all the centuries who looked up at the same dark and asked the same questions, all of them your kin, all of them part of the same reaching. You are not alone in the dark. You never were. You are one of a great and ancient company of watchers, and the watch can be handed on now, and you can close your eyes and let the light you carried settle into the quiet and rest. The night is deep now, and there is nothing left to do but drift. Let me stay beside you a little longer, my voice growing softer, the words slowing, until they are only a gentle sound in the dark, a companionship you no longer need to follow, only to feel. You are safe. You are held, and sleep is very near. Let me leave the great images with you one final time, softly, not to teach them, but to tuck them in beside you, familiar now, like old friends settling down for the night. The door that opens inward, the black hole, real and everywhere, silent and patient at the hearts of galaxies. The door that opens outward, the white hole, the fountain that never poured, the road the universe declined to take, still drawn in the quiet equations and never once built in the sky. And between them, the single arrow of time, flowing forward, always forward, carrying every star and every galaxy and every ancient beam of light, and carrying you too, gently down toward morning. The shattered glass that never mends, the spreading ink that never gathers, cooling cup whose warmth spreads out into the room and never returns. All of it, the whole one-way flow of things, the arrow that forbids the fountain and gives your life its weight. let it flow now. This night become the past, safely, permanently, kept forever in the great honest ledger of what has been. Let tomorrow stay ahead of you, unreached, waiting, sure to come in its own time, carried to you by the same forward current that carries the light of the stars. You do not have to reach for it. You do not have to hold on to tonight. The river of time will do all the carrying. You need only float. Feel, one more time, the weight of your body sinking into what holds it, heavier now, warmer now, more willing to let go than it was even a few breaths ago. Feel the slow rise and fall of your breathing, that oldest rhythm, asking nothing, giving everything, carrying you down with each long, soft exhale. There is nowhere to be. There is nothing to finish. The wheel of the galaxy turns slowly, as it has for billions of years, and you turn with it, a small warm point of quiet in the enormous gentle dark, held on every side by things too vast to name, needing to hold nothing yourself. If a last thought drifts by, let it drift. If a fragment of the day, or a fragment of all we spoke of, some door, some star, some distant ancient light, floats across your mind, let it float on past, the way a cloud crosses the night sky, while the stars behind it stay. You are the sky. The thoughts are only clouds. They come and they go, and you remain wide and dark and calm, holding them gently and letting them pass. Soon even the clouds will thin, and there will be only the sky, only the quiet, only the slow breath, and the sinking weight, and the vast soft dark that made you and holds you and asks nothing of you at all. You are made of stars. Iron in your blood, the carbon in every living part of you, forged in the hearts of suns that died before the earth was born and scattered out into the dark and gathered again over unimaginable time into you. You are not a stranger to the vastness. You are the vastness, come briefly awake, resting now, ready to sleep. And when you sleep, you do not leave the cosmos. You settle deeper into it, a small beloved part of the whole, carried onward by the forward flow of time, kin to every star, and every silent door, and every ancient beam of light still crossing the dark towards some far shore. There is nothing to fear in the size of it. There is nothing to fear in the strangeness of it. The doors in the dark are far away and silent, and they do not disturb your rest. The white holes that never were do not trouble the night. The black holes at the hearts of the galaxies hold their cities of stars gently and ask nothing of you. All of it turns on, vast and ancient and calm, a great quiet machine of light and time, and you are held safely within it, in your small warm corner, breathing slowly, letting go. So let go now the rest of the way. Let the last of the day dissolve. Let the last of the words become only sound, and then let even the sound fade until there is nothing left but the dark, and the warmth, and the slow tide of your breath carrying you down and down, and gently down, into sleep. And so the journey that began beneath the stars circles back, at the very end, to where it started. We began tonight with a single door, standing alone in the dark, a door that only opens one way. And we have wandered from that door all the way out to the edge of what anyone knows, through the mathematics of a soldier and the maps of two low mines, through the naming and the bridge, through the great walls of thermodynamics and instability, out to the far frontier where a black hole might yet bounce and become its own mirror twin. And now, gently, we return to the door where we began, and we find it still standing there in the quiet dark, unchanged, patient, waiting, as it has waited inside the equations for more than 100 years. The door that only opens outward, the fountain that only spills, the white hole, that beautiful thing the universe wrote into its own rulebook, and then, so far as we can tell, quietly declined to build. It is still there, still allowed, still absent, still a road not taken in the deep grammar of the cosmos. And now we understand, as well as anyone can, why it stays unbuilt. Because the universe flows forward. Because time has an arrow. Because the same one-way current that forbids the fountain is the current that carries your whole life and gives each of your moments the weight of happening only once and keeps your past forever safe in the ledger of what has been. The missing white hole and your own forward journey through time are, at the deepest level, the same single gentle fact. And that fact has carried you all night long, all the way here to the edge of sleep. There is nothing left to understand now. There is only rest. The great question is answered as honestly as it can be, which is to say with wonder still living in the gaps, and you can let it go completely, the way you let a whole day go as you fall asleep, keeping only the warmth of having wondered, of having reached out towards something vast and beautiful, and been, for a little while, filled by it. The names may drift away. The numbers may drift away. Only the feeling need remain, the quiet feeling of being small and welcome and held, a warm and breathing part of an enormous and gentle dark. Let your breathing slow now, all the way. Let each breath out be softer than the last. Let your body grow heavy, fully heavy, sinking into what holds it, held by the bed, and the bed by the floor, and the floor by the patient turning world, all the way down. There is nothing you need to carry. There is nothing you need to do. The wheel of the galaxy turns, as it always has, and you turn with it, carried without effort, a small warm point of quiet in the vast soft dark. Thank you for wandering with me tonight, all the way out to the strange doors in the dark, and all the way back again. If this quiet hour brought you some peace, you might find your way back here another night, whenever you need a gentle voice and a vast and calming sky, or you might share this quiet with someone you love who needs a little rest of their own. But that is for another time. For now, there is only this. The dark and the warmth and the slow tide of your breath. Let your breathing slow. Let your body grow heavy. Let the vastness hold you the way it holds every star. You are made of it, and you belong to it, and it will keep you gently all the way down into sleep. Rest now. Good night.